Hello, and welcome to the Snoozy Scientist. I'm really glad you made it here tonight. Wherever you are on this little blue planet, this gentle corner of calm has been made specially for you. A calm space where science and wonder can sit side by side, gently putting you to sleep. Tonight, we're going to slip far back through time, beyond history, beyond memory, to uncover one of the strangest mysteries written into the story of life itself. Because more than 99% of all species that ever lived are gone, erased by time, leaving behind only fragments of bone and shadow. And yet, across all those ruins, something remarkable keeps happening. Evolution, we're told, is wild and unpredictable, a story written by chance and chaos. And yet, time and again, it circles back to the same designs in eras that never should have remembered each other. Across ages separated by hundreds of millions of years, life keeps rediscovering the same colossal forms. Predators with the same sleek outlines returning to different oceans, towering grazers rising from entirely new lineages, wings vast enough to darken the sky, built on bones that never knew their ancestors. Not the same species, not even distant cousins. It's as if nature is telling the same story over and over, only changing the cast. But why does nature do this? Why does it rebuild what it already erased? Are these shapes somehow inevitable, the only solutions the laws of nature allow? Or does life itself carry a faint memory of what once ruled the world? Tonight, we'll drift through that mystery, through the ages when the same giants walked the earth more than once. We'll follow the strange rhythm of evolution as it repeats its greatest creations and wonder what hidden rules guide its hands. But before we begin, if you're already enjoying this calm space, it would mean so much if you gave this video a gentle like, maybe even subscribed, if you'd like more sleepy science stories like this. And if you feel comfortable sharing, let me know in the comments. Where are you tuning in from tonight, and what time is it there? It's always a joy to see how far across the world these gentle science stories travel. So now, take a slow breath, let your shoulders soften, and together, let's begin our journey into why evolution made the same giant creatures twice. Before we move deeper into the repeating giants of Earth's story, we need to settle gently into the quiet ground beneath everything, the deep, patient process that has shaped every creature we have met so far, and every creature we will meet next. Evolution is often spoken of as if it has plans or intentions, as if it sits in the shadows, choosing favorites or guiding certain forms toward greatness. But the truth is much softer and far more wondrous. Evolution does not think, it does not aim. It simply leans, slowly and quietly, toward whatever allows life to survive long enough to continue. It is a story told through tiny changes that drift across generations, a shift in a bone, a slightly stronger muscle, a shell that bends in a way that offers just a little more safety. Over millions of years, the smallest differences can become entire worlds of possibility. And yet, even with all this freedom to wander, life does not explore endlessly in every direction. Something steadies its steps, something shapes its choices. Natural selection is often described with sharp lines and precise language, but in the calm of deep time, it feels more like a quiet filter. Countless forms arise, but only those that fit their surroundings in that moment linger. A creature that swims just a little more efficiently, one that can hide a little better, one that wastes a little less energy. These small advantages become the direction of the future. There are limits gently woven into every landscape. A forest can only feed so many giants. A shallow sea can only lift bodies that find a balance between weight and buoyancy. Even the air places quiet boundaries on wings and bones. These limits do not erase creativity, they simply give it shape, the way the banks of a river guide the flow of water. Life fills the spaces available to it, and when those spaces are similar across time, the shapes that fill them often seem to return. This is why evolution, though it has no memory, often arrives at similar answers. Scientists call this convergent evolution. It is what happens when different families of creatures, with different histories and different beginnings, are pushed by the same pressures toward the same solution. It is less a coincidence and more a soft reminder that Earth follows rules too. Water pulls bodies toward smooth curves. Air needs strong lift to hold anything large. Gravity presses every living thing to find balance between strength and weight. Picture oceans separated by hundreds of millions of years. One belongs to a world where strange armored fish ruled. The other belongs to an earth already home to birds, flowers, and forests that would have seemed impossible in earlier ages. Yet both oceans cradle the same calm truth. If a creature must move quickly through water, its body will tend to narrow into a shape that glides. Eyes drift forward. Fins settle into positions that catch the flow. Whether the creature is a reptile or a mammal does not matter as much as the water itself. The ocean chooses the shape long before the species arrives. Land tells its own quiet story. When forests spread across wide continents and food becomes abundant, something remarkable begins to unfold. Large bodies become more efficient. A huge animal loses heat more slowly. It can travel far without tiring. It can reach high leaves that small animals cannot touch. But this only happens when the world is stable enough to feed something so big. Giants do not appear during chaos. They grow from calm stretches of time when climate, food, and space hold steady long enough for them to flourish. Air has its own laws, perhaps the strictest of all. Wings must be light but strong. Muscles must be powerful but not too heavy. If the atmosphere becomes richer or denser, the sky welcomes larger wings. When it thins, flight becomes delicate again, and the giants of the air disappear. Every era has its own balance, and the creatures that rise to claim the sky are shaped by the invisible weight of the air itself. Across all of Earth's history, gigantism has appeared only during special conditions. Oceans need bursts of nutrients that allow filter feeders to expand into astonishing sizes. Forests need long periods of warmth and stability to support colossal herbivores. Predators require prey that is plentiful enough to sustain large bodies. When any part of this balance shifts, the giants fade, like a tide pulling back into the deep. So evolution does not choose giants because it wants them. The world chooses them because the world is ready for them, and when the world changes, it chooses them again. Here in this gentle clarity, we begin to see why the same enormous forms return in distant ages. Evolution may not plan ahead, but Earth writes its own quiet rules. When the same pressures repeat, the same shapes rise again, and so the story of life becomes a long and patient echo carried across oceans, continents, and eras that never knew each other. This is our foundation, the soft ground beneath the mystery. From here, the journey through repeating giants can truly begin. To understand why giant forms return again and again in Earth's long story, we drift now into a world so old that its sunlight seems unfamiliar. The continents are scattered pieces of stone, the air carries a different weight, and the oceans, still young in spirit, shimmer with colors that no living eye has ever seen. Here, in this deep past, life is small and cautious, yet the waters already hold the seeds of something grander. As we sink gently beneath the surface, the world around us quiets. Tiny creatures drift like dust caught in a long ray of morning light. simple bodies, soft forms, and a rhythm that feels slow and ancient. Then, through this haze of early life, something begins to rise, a long shape, pale and elegant, gliding with a patient confidence that sets it apart from everything around it. It is the first of the ocean's great giants, an orthicone cephalopod, its body shaped like a tall, tapering tower of living stone. These creatures were unlike anything that came before them. Most early animals stayed close to the seafloor, hugging familiar ground, but the orthocones lifted themselves into open water. Their shells stretched upward, long and straight, giving them a shape that could cut through the currents with quiet ease. They moved by taking water in and pushing it out in gentle pulses, a simple method of motion that suited the slow, steady world they lived in. Through this simple propulsion, they became the first large predators to roam the open sea. In these primordial waters, being big was not a luxury, it was a chance to experiment with possibility. The ocean itself encouraged this growth. Water holds weight softly, so even a long, rigid shell can float if it balances its gases just right. Where land pulls downward without mercy, the sea cradles what it carries. And so these early giants rose through the depths, not as burdens to the world, but as quiet explorers of a realm where size could stretch a little farther with every generation. Their bodies were simple, yet their presence shifted everything around them. Small creatures that once drifted freely now learned to flee or hide. New shapes evolved to escape their slow, graceful hunts. Others grew thicker armor to survive the pressure of their grasp. The orthocones did not rule with speed or cunning. Their strength came from patience and from the long reach of their bodies, which allowed them to drift into places where smaller hunters could not follow. As we glide beside one of these ancient giants, we can see how the ocean shaped it. The long shell acts as a kind of keel, keeping its movement steady in the shifting currents. The creature's soft tentacles, tucked beneath the narrow tip of its shell, reach outward with quiet care. Life here is measured differently than in later ages. There is no rush. The sea moves slowly, and these giants move with it. The early oceans favored long shapes because water rewards anything that can slip through it with the least resistance. It is a world that sculpts bodies the way wind shapes dunes, smooth curves, tapered ends, and forms that can push aside the weight of the sea without wasting energy. The orthocones were shaped by these rules, carved by the quiet physics of their home. Their size gave them safety. Few creatures dared to challenge something so tall and balanced. Their shells protected them from sudden bites. Their reach allowed them to rise above crowded seafloors and feed in open water where food drifted freely. The ocean offered them a wide canvas, and they grew into it with slow determination, yet their size also connected them to the world around them in delicate ways. Being large meant needing more food, more space, and a steady rhythm in the environment. These early giants thrived in a time when nutrients flowed richly through the seas and plankton bloomed in soft, drifting clouds. The ocean's generosity allowed them to stretch upward and outward, exploring the possibilities of what life could become. Every small shift in the environment left its mark on them. Temperature, minerals, sunlight filtering down through shallow seas. All these gentle forces shaped the ways their bodies grew and the roles they played. Time, their presence became an echo that would stir again in future ages, long after these early forms faded away. For now, though, we float beside them in their quiet world. The water is warm, the currents move slowly, and the first giants of earth glide through the ancient sea with a calm confidence, unaware that they are the beginning of a pattern the planet will repeat many times. The ocean cradles their long forms, the light fades softly above us, and we drift with them for a moment longer, in the place where the story of repeating giants first began. The ancient orthocones drifted through oceans that no longer exist, and their long, quiet reign left a faint trace on the world, not a memory, because evolution has none, not a legacy, because the line that carried them forward ended in silence. What lingered instead was something softer, a shape that fit the ocean so well that the sea itself seemed to hold the pattern, waiting for the right moment to let it rise again. Time moves far from that early world. The seas shift, continents change their places like slow dancers crossing a vast and patient floor. New creatures bloom in the open water, and others fade quietly into the dark. When the ages circle back to warmth and stability, the oceans begin shaping new giants that echo the old ones, not through ancestry, but through the simple pull of physics. We find ourselves floating in a younger sea, although it is still impossibly ancient by our own measures. The water is clearer, light reaches deeper, life has grown more complex, with shells that twist into spirals and bodies that fold into shapes more delicate than anything the early oceans held. And there, rising from the shadows of the sea floor, is a form that feels familiar, even though it belongs to a different world. The ammonites have arrived. Instead of the tall, straight shells of the orthocones, these new cephalopods carry coiled homes that curve like quiet spirals of stone. Their bodies spill outward from the opening, soft and keen, guiding them through the water with gentle pulses. Drift after drift, they move through the ancient seas, exploring spaces that their long bodied predecessors once touched. Yet they are not descendants. Their lineage grew along a separate path, branching from a different ancestor, shaped by different environments. The resemblance comes not from blood, but from the timeless conversation between water and form. Ammonites grew into many sizes, but in certain eras, some reached lengths that rivaled the giants of earlier times. Their spiral shells gave them balance. Their simple propulsion, still powered by small pulses of water, let them glide across the seas with quiet confidence. When we watch them move, we can see how the ocean coaxed them into their shape. A spiral shell resists crushing pressure. It spreads force through its curve, the way a wave spreads its strength across a long shoreline. This made ammonites resilient travelers, able to survive deeper waters and stronger currents. As we drift beside them, the water hums softly with distant life. Schools of smaller creatures turn like glimmering clouds. Shadows of larger hunters move with steady grace. The ammonites are neither the fastest nor the fiercest, yet their form grants them a gentle advantage. Their shells serve as anchors, keeping their bodies steady in rising currents. Their tentacles give them reach, and their coiled design, so different from the towering orthocones, still follows the same quiet rules the ocean sets for all who roam its depths. In time, as the world continues to change, another group of cephalopods emerges to take on the role of giants once more. These new creatures have no external shells. Their bodies are long and soft, shaped by muscle instead of stone. They do not resemble the ammonites. They do not resemble the orthocones. Yet their presence carries the same calm truth. The ocean has found another way to create a long-bodied giant. These early squid-like predators rise into the open water with grace that feels almost otherworldly. Their bodies narrow into sleek shapes that slide through the sea without effort. Their arms and tentacles trail gently behind them, moving with the slow rhythm of drifting currents. The simplicity of their motion belies their power. By pulling water into their bodies and pushing it out in steady bursts, they travel with surprising speed when needed. It is the same method used by the giants of long ago, yet now expressed through a different body, a different lineage, a different time. Here, the quiet influence of physics becomes clear. Water rewards creatures that can move with minimal drag. Long shapes work well, smooth bodies work even better. Whether carried by a shell or by soft muscle, This design allows a creature to push through the dense embrace of the sea without wasting precious energy. The ocean, with its weight and flow, guides life toward forms that obey its laws. When a lineage finds a shape that fits those laws, that lineage thrives. When a lineage vanishes, the ocean does not change its rules to mourn the loss. Instead, when conditions allow, another creature rises and finds the same answer because the sea still asks the same questions. This is why giant cephalopods returned, not as echoes of the past in a genetic sense, but as echoes of physics shaped by the same pressures that touched the ancient orthocones. The shell might change, the limbs might change, but the quiet reward for long bodies and simple propulsion remains. We drift through this world of spirals and shadows for a moment longer, watching the giants glide through their realm. The water moves around them as gently as breath, and in their shapes we see the soft truth that the oceans have carried across the ages. Forms that work well do not stay buried in the past. The world finds them again, each time with new hands. The sea has always been a patient sculptor. It does not carve with sudden force, but with the slow, constant insistence of movement and pressure. Over millions of years, water teaches every creature that enters it how to live within its quiet rules. As we drift forward through time, far beyond the age of spiraled shells and drifting cephalopods, we arrive in oceans that carry a new rhythm. These waters hold hunters built for speed, precision, and the graceful stillness that comes before a sudden strike. The world of the ichthyosaurs rises first. These ancient reptiles ruled seas long before whales and dolphins ever existed. When we look at them through the gentle filter of deep time, their shape feels almost modern. Their bodies narrow into sleek forms that slice through the water with little resistance. Their snouts stretch forward like careful arrows. Their tails curve into powerful flukes that push them across open seas with smooth pulses of force. Their limbs, once shaped for land far in their ancestry, have transformed into paddles that guide them with quiet accuracy. These reptiles did not copy the whales that would come after them. They swam in oceans separated by vast ages. Yet the moment an ichthyosaur swims past, its outline carries a familiar calm. It is the outline of a creature that has learned the ocean's lessons. Water favors curves over corners. It favors a body that grows narrow at the front and widens in the middle before tapering again. It rewards anything that lets the sea flow around it without stirring too much turbulence. And the ichthyosaurs listened. They glide through warm, ancient waters, their shadows tracing smooth lines across sandy seafloors. The sunlight above them dances in fractured patterns. Their movements send soft currents into the world around them. They are hunters, yet their presence feels peaceful here, guided by the same physics that shaped the earliest giants of the sea. But their mastery of speed brings a new kind of elegance. Their large eyes shimmer with the faint glow of distant light, allowing them to navigate both bright shallows and deeper, darker places. Time turns again, slow as the settling of fine sediment on a quiet seabed. The ichthyosaurs vanish, leaving only the delicate record of their bones. Entire oceans rise and fall in the ages that follow. New creatures appear, shaped by new pressures, heat shifts, ice advances and retreats. Continents drift apart like silent rafts. And when the world settles into another long stretch of stability, the ocean begins its patient shaping once more. This time, the giants that rise are mammals. Their ancestors walked on land. They breathed open air beneath wide skies. Yet the sea called to them, just as it had called to the reptiles long before. Slowly, generation by generation, these land-bound animals returned to the water. Their bodies changed in small increments. Legs turned to fins, tails stretched and flattened. Their bodies grew smooth, Their breathing adapted to long dives, and over the ages, the dolphins and whales appeared, carrying the same refined outline that the ichthyosaurs once wore. When a dolphin arcs through clear water, the resemblance is unmistakable. A sleek body, a tapered snout, a fin placed just right to balance the roll of the sea, a tail that moves with rhythmic strength. Everything about the shape feels intentional, yet it was not designed. It was encouraged, quietly and constantly, by the physics of water. Whales, even the largest ones, follow this same quiet rule. Despite their size, they move with grace. Their bodies slip through the ocean as if the water welcomes them. Their enormous tails create slow, powerful waves that travel behind them like soft echoes. Their forms mirror the ancient ichthyosaurs, not because they share an ancestor who taught them how to swim, but because the ocean itself teaches every creature in the same way. If you want to move far, move easily. If you want to move fast, reduce every bit of drag. The sea rewards simplicity, balance, and smoothness. We drift beside these modern giants for a moment. The world around them feels calm, as if shaped by the slow beat of their movement. Their size does not disrupt the water so much as it folds into its rhythms. Light dances on their backs. Tiny fish gather in their shadows for safety. Everything moves in soft harmony. The repeated shape of the apex ocean hunter, whether reptile or mammal, reveals a quiet truth. The ocean does not favor one lineage over another. It simply offers the same challenges to all who enter. Move through heavy water, conserve energy, catch prey that can dart away in an instant, survive long enough to pass on your form. Across different eras, different families rise and fall, yet the shape that solves these challenges repeats. It is not a memory of the past. It is the ocean's way of nudging life toward the form that works best, again and again. And in this gentle understanding, we see how the sea shapes giants with a patient and unchanging hand. As we drift onward through the long story of Earth's oceans, the world around us softens again into a different age. The sharp outlines of ancient hunters fade, and in their place we begin to sense a gentler presence rising through the water. It is a reminder that not all giants come from speed or strength. Some come from patience. Some come from abundance. And some arise simply because the sea becomes rich enough to carry them. Long before the modern whales, long before the great bony fish that once stretched across ancient seas, the earliest filter-feeding creatures began their quiet work. They were small at first, no larger than a hand, drifting through warm waters thick with life. They opened their mouths to the currents and let the ocean bring food to them. Plankton, tiny fragments of organic matter, and delicate drifting organisms all passed through their gill structures. The smallest particles stayed for nourishment. The rest continued on their way, caught again by the ponocam, currents that never truly rested. For these early fish, the sea was generous. In those ancient waters, nutrients flowed from restless volcanoes and shifting seafloors. Sunlight reached through shallows, feeding vast blooms of plankton. When food becomes plentiful and easy to gather, a quiet opportunity appears. Small filter feeders begin to grow. Their mouths widen, their bodies stretch, their gill structures become more efficient at catching the drifting wealth around them. Each generation finds slightly more advantage in size, until the ocean shapes something much larger than the tiny creatures that began the pattern. Time moves forward, slow and steady. The world changes, yet the sea continues to provide. Eventually, the oceans cradle enormous bony fish with wide mouths that open like calm gates. These giants swim with slow strokes, letting the water wash through them. Their bodies are built for volume rather than speed. Their strength lies not in pursuit, but in letting the world flow toward them. They are living harvesters, gliding through a sea rich enough to support their size. The reason filter feeders grow so large is gently woven into the physics of water itself. When a creature feeds by letting the ocean pass through its mouth, the amount of food it can gather increases with the size of the opening. A larger mouth takes in more water with each sweep. A larger body can support wider filtering structures, and at a certain point, size becomes a quiet advantage. The giant does not need sharp teeth or powerful jaws. It only needs space enough to let the sea pour through. During certain eras, the oceans became especially productive. Nutrients surged through the waters as continents shifted and climates warmed. Plankton blooms spread into great curtains of life, feeding everything around them. This richness created room for giants to rise again. Each time it happened, filter feeders answered the call. Their bodies expanded into the open blue, their mouths grew wider, their movements slowed, becoming more efficient as their size increased. They turned the act of feeding into a gentle, continuous rhythm that matched the pulse of the sea itself. In the present day, the oceans hold the largest animals that have ever lived. Modern whales, especially the great baleen whales, are the latest expression of this recurring pattern. They belong to a lineage far removed from the early fish and the ancient bony giants, yet their bodies reflect the same quiet truth. When the ocean grows rich, life moves toward size. A baleen whale swims beside us now, its presence vast yet calm. Its mouth stretches open in a soft arc as it moves through a cloud of drifting plankton. The water rushes in, bringing with it countless tiny organisms. Inside the whale's mouth, comb-like curtains of baleen catch the food while the water flows back out. This method is simple in spirit, yet deeply shaped by physics. The larger the mouth, the more water it can process. The more water it moves through, the more nourishment it gathers with each slow glide. As the whale continues forward, the sea around it swirls in gentle spirals. A single pull of its massive tail carries it farther than a small creature could travel with many strokes. In this way, size becomes a tool for efficiency. A giant can travel long distances without tiring. It can gather tremendous amounts of food with minimal effort, and it can roam through entire oceans, guided by ancient instincts that follow the shifting patterns of plankton blooms. The rebirth of giant filter feeders shows us that the ocean does not forget the shapes that work best, not through memory, but through balance. When nutrients gather in great abundance, the sea invites creatures to grow wide and long. When conditions change, those giants fade, only to rise again when the waters return to their generous state. For now, we drift alongside a whale as it continues its quiet journey, the waters shimmering around its vast body. In its slow movement, we feel the echo of ages, a shape that appears again and again, carried not by lineage, but by the enduring rhythm of the sea. As our journey drifts deeper into Earth's history, the light around us shifts again. The calm blue of the oceans dims into a world shaped by resets, recoveries, and second chances. After each great change, life gathers itself, rises slowly, and begins to rebuild the delicate structure of ecosystems. And in these moments of rebuilding, something powerful often emerges. The oceans, still settling from the old world, begin to craft new hunters. Their shapes are different in each era, yet their presence carries the same quiet weight. They are giants built not for elegance or speed, but for strength. They are the armored ones. We begin far back in the Cambrian seas, where life is still young and experimenting with form. The water is filled with soft-bodied creatures that drift and crawl across strange seafloors. Into this gentle world comes a shape that feels almost out of place, like a whispered hint of what the oceans will someday hold. Anomalocaris glides above the rippling sand, its body rippling with careful motion. Its large eyes shimmer with a clarity that few creatures of its time can match. Along its sides, flaps move in a rhythmic wave, sending it forward with calm efficiency. It is not armored in the way later giants will be, but its body is sturdier than most of its neighbors. Its frontal appendages curl and unfold with deliberate control, gathering prey with a softness that hides the strength beneath. In a world where defenses are still simple, Anomalocaris rises as a quiet force. It is the first large predator to roam open waters, shaped by a time when the ocean had only just begun to explore the idea of size. Millions of years pass, entire lineages fade, the oceans warm and cool, continents gather and separate. Then, long after Anomalocaris has vanished, the seas create a new kind of armored terror. We enter the Devonian, where reefs glow with life and fish of every shape swim through coral forests. Here moves Dunkleosteus, a creature so heavily built that water seems to part reluctantly around it. Its head and chest are encased in thick plates that fit together like ancient stonework. These plates do not weigh it down, but anchor tremendous power within. Where Anomalocaris hunted with grasping limbs, Dunkleosteus uses jaws that work like living blades. When they close, the plates slide past one another with incredible force, crushing shells and bone with ease. It is a giant made possible by a world recovering from earlier upheavals, a world where ecosystems have grown rich again but still hold open space for new rulers. This pattern, subtle yet steady, unfolds again after later extinctions. When a great collapse empties the seas of their largest predators, the world enters a period of quiet. The surviving species wander through newly open waters, no longer overshadowed by older giants. Food webs begin to rebuild from the ground up. And when stability finally returns, the ocean often shapes a new apex hunter, one that rises quickly to fill the role that vanished in the previous age. In the ancient Cenozoic seas, long after Dunkleosteus is gone, this role is taken by the ancestors of megasharks. The world has just recovered from the extinction that ended the age of the dinosaurs. Marine reptiles are gone. Large fish-eating predators have disappeared. The oceans are once again open, rich, and waiting. Into this emptiness swim sharks that begin small, then grow larger as food becomes plentiful and competition remains low. Their bodies are not covered in armor like Dunkleosteus, but thick skin and dense muscle give them a different kind of resilience. Their teeth grow long and serrated, shaped by the steady motion of hunting through open water. With each generation, size becomes more advantageous. Prey is large, space is vast, and nothing from the old world remains to challenge them. As we drift beside these giants in each of their eras, a quiet pattern reveals itself. After extinctions, the ocean becomes a place of cotters, open opportunities. Predator roles empty out. With no giant hunters to hold their place, smaller species rise and expand, gradually evolving into something larger. The cycle does not depend on ancestry, it depends on vacancy. When the ocean resets, nature begins the slow work of filling empty spaces again. Armored or heavily built predators arise because early ecosystems after an extinction are unstable. Prey species multiply quickly, competition is low, resources are abundant. In such worlds, strength is a powerful strategy. A creature that can dominate a wide range of prey will thrive. And once it becomes the largest hunter in its world, its form settles into the structure of the ecosystem until the next great collapse. Each era shapes its giants differently. Some carry plates of bone, some carry jaws that can shear through anything in their path, some carry muscles so thick that their silhouettes cast wide shadows across the water. Yet the pattern behind them remains the same. The ocean clears its stage, then invites new rulers to rise. For a moment, we float quietly at the center of these shifting worlds. The armored silhouettes drift around us like echoes of forgotten ages. Different shapes, different times, the same quiet story. As our journey leaves the oceans behind, the water around us softens into mist. The world brightens. The deep blue lifts upward into pale open sky. For the first time in this long drifting story, we rise with the air instead of sinking with the tides. Here, above the shifting lands and changing seas, a different kind of giant takes shape. Its body is carried not by water, but by something far more delicate. The sky becomes a stage for creatures so large that their wings seem too fragile to hold them, yet they move with grace that feels almost weightless. The first of these giants belonged to the age of the pterosaurs. They rose in a world where forests of strange trees stood tall and rivers wound through lands filled with reptilian shapes. The air was warmer then and thicker with the breath of ancient plants. When a pterosaur opened its wings, the sunlight passed through the thin membranes like light through soft silk. These creatures were not birds, although they shared the sky with early feathered forms. Their wings were supported by long arms, and a single elongated finger held open with quiet tension as they glided across warm currents. We drift near them now, watching as they take gentle leaps from high cliffs. Their bodies are light, but their wings are vast. Some stretch wider than a small aircraft of our time, though they move with a softness machines can never match. Each beat of their wings is slow and measured, guided by the physics that governs all flight. Lift rises from the shape of their wings. Drag whispers against the surface of the air. Gravity pulls them downward, and thermals carry them up again. In these careful balances, the first giants of the sky were born. Flight gives freedom, but it also brings limits. The air can only support bodies of certain sizes. Wings must reach and curve just so, spreading weight over a wide surface. Muscles must be powerful enough to lift, but not so heavy that they drag the creature down. Every sky has its own rules, shaped by air density, climate, and the composition of the atmosphere. During the age of the pterosaurs, Earth's air was thick enough to help support large wings. Warm winds rose in steady columns from sunlit ground. These conditions allowed creatures to grow immense, their wings stretching wider with each passing age. But time carries all things forward. When the pterosaurs finally vanished, their departure left the sky empty of giants. Smaller birds fluttered through forests and marshes, but none yet dared to grow larger than the air would easily allow. For a while, the world's skies returned to quieter forms. Then, slowly, the balance shifted again. Climate patterns changed, new ecosystems stabilized, food sources spread, and once more, life began shaping wings into something grand. We move now into a world shaped by birds, long after the last pterosaur glided above the ancient seas. Here, new giants emerge. Their bodies are covered in feathers, and their wings move with strong, rhythmic strokes. They are heavier than their reptilian predecessors, but they follow the same delicate physics. To fly, they must be light enough to rise but strong enough to endure long hours in the air. Some settle into flightlessness, using their size to rule the ground. Others remain airborne, navigating through open skies with wings that stretch broader than the horizon's curve. Among them are the extinct giants like Argentavis, a bird with wings large enough to cast shadows across hillsides as it soared. Its bones were hollow but sturdy, its feathers shaped to catch the wind. It relied on rising air, just as the pterosaurs did. It glided across vast distances, sometimes traveling for hours without a single wing beat. And though it belonged to a different lineage, separated by millions of years from the ancient reptilian flyers, its silhouette against the sky feels hauntingly familiar. Convergent evolution reveals itself clearly here. Both pterosaurs and giant birds carried entirely separate histories. Their ancestors walked different lands, ate different foods, and breathed different atmospheres. Yet both arrived at shapes that echo one another, because the sky, like the sea, demands certain answers. To glide, wings must be long. To support heavy bodies, wings must be broad. To control direction, tails and feathers or membranes must balance the shifting currents around them. The air offers little forgiveness. A creature too heavy will fall, a wing too small will fail. But when all parts align, the sky becomes a place where giants can drift with near endless freedom. As we rise higher, the wind smooths into a gentle hum. The world below becomes soft in the distance. Pterosaurs glide through one age. Giant birds glide through another. Their shadows pass over different forests, different oceans, different mountains, yet the air carries them both with the same calm understanding. Flight has reinvented giants more than once, not because of memory, but because the sky allows only a narrow path for large bodies. And whenever life grows bold enough to follow that path, the same beautiful shapes unfold again, lifted by the same ancient laws that rule every breath of wind. As the winds of ancient skies fade behind us, we descend once more to the solid comfort of land. The continents stretch wide beneath the sun, each carrying forests, plains, and long winding rivers. Here, on firm ground, a different kind of giant rises, not a hunter that slices through water, not a glider lifted by warm currents. These giants walk slowly, shaping the world with every steady step. We begin in a time when the earth is warm and green, and forests spread like great blankets across the continents. Ferns rise in gentle layers, tall conifers stand in calm rows, and moving through this ancient scenery are the sauropods, the long-necked giants of the deep past. Their bodies look almost unreal against the quiet landscape. Legs like columns, tails that sweep behind them in long, balanced arcs, necks that stretch toward treetops, tracing a slow path through the leaves. A single sauropod can reshape the world around it. Each breath draws deeply from the warm air, each step presses into the soil, leaving soft impressions that fill with water after the rain. These creatures reach upward for food few others can touch. Their long necks rise above dense thickets, above cycads and ancient palms, allowing them to graze where competition is thin. In a stable world with abundant plants, size becomes not a hindrance, but a quiet advantage. Being large brings safety too. A body so immense discourages most predators. Even young sauropods, though vulnerable, grow quickly, soon towering above any creature that considers challenging them. Their slow hearts pump through thick arteries. Their stomachs ferment great volumes of plant matter. Their lives move with patience, shaped by the simple certainty that the world around them can support their size. But time does not stay still. Ages shift. Climates cool and warm again. Entire forests disappear and reappear in different forms. The sauropods eventually leave the world, their lineage fading into silence. For a while, land is ruled by smaller animals, quick and cautious. Yet when stability returns, when the earth once again settles into long periods of calm seasons and steady plant growth, the pattern reemerges. This time, the giants rise from a new lineage. Mammals step into the open plains, carrying with them a quieter strength. They begin small, shaped by ages spent in the shadows of earlier rulers. But as the forests change and open grasslands spread across continents, certain mammals start to grow. Their bodies lengthen, their legs thicken, their appetites widen to match the new abundance around them. From this slow transformation come the first great herbivorous mammals. Some resemble grand rhinoceroses, others resemble towering ground sloths. Many become enormous grazers that roam in herds across ancient meadows. The largest reach sizes that echo the sauropods in spirit, though they differ in form. They chew differently, they move differently. Their bones carry weight in new ways, yet they share the same gentle purpose of drifting across wide landscapes and gathering the world's greenery into their long digestive chambers. And then, from this flourishing diversity, the elephants appear. Their ancestors move quietly through forests dense with sound and scent. Over time, their bodies grow larger, their tusks lengthen, their trunks become versatile tools for reaching, grasping, and sensing the world. Eventually, some elephants evolve into the largest land mammals that have ever lived. In their presence, we see a new reflection of the old pattern, repeated on a different canvas. Elephants do not rise because they remember the sauropods. They rise because the world once again allows them to. When ecosystems stabilize, when food grows predictably across long distances, when predators cannot threaten mature individuals, when climate remains gentle enough for slow growers to thrive, the path toward gigantism opens. Life steps onto that path with the same quiet inevitability it once followed in ancient forests. Being huge on land is a kind of energy efficiency. Large bodies hold heat more steadily. They retain warmth through cool nights. They wander far without losing strength. Their sheer mass helps them ferment tough plants into nourishing meals. And in open environments, where winds sweep across wide plains, a giant can travel wherever food leads. Yet these giants do not dominate through aggression. They shape their world through calm persistence. Their steps carve trails through grasslands. Their feeding patterns prune trees and clear passages for smaller creatures. Their presence changes the rhythm of entire ecosystems, not through force, but through size and time. We drift beside them now. The earth vibrates gently beneath their weight. Sunlight glints across their backs. Dust rises softly with each step. Though they belong to a world far removed from the sauropods, the echo remains unmistakable. Both lineages, separated by millions of years, grew large when the land allowed them to. Both filled roles that always return when forests spread wide and food grows plentiful. Across different ages, in different forms, the land has shaped its own gentle titans again and again. Creatures that walk rather than fly, creatures that feed rather than hunt, creatures that carry the quiet patience of Earth itself in every slow, deliberate step. For a moment, we walk beside them, hearing the faint rustle of leaves and the distant call of smaller animals weaving through their shadows. The pattern unfolds softly beneath the warm sun, a reminder that the land, like the sea and the sky, writes its own stories in repeating lines. As the quiet footsteps of the great land herbivores fade into the distance, the world around us settles into another shape. We walk across a landscape where sunlight glows warmly on leaves that rise in layered canopies. Soft winds pass through branches that stretch far above the ground, carrying scents of flowers, bark, and distant rain. In this peaceful place, forests of many ages unfold before us like pages in a drifting dream. And through these forests, another familiar pattern emerges. It is not the pattern of sheer size alone, but of height, of reach, of a body shaped to touch what others cannot. Long necks return. They rise through different eras, belonging to different families, yet always serving the same quiet purpose: to lift the head above the crowd, to find food that waits not near the soil, but in the high mosaic of leaves shaped by shifting sunlight. We stand once more in the deep past, though far ahead of the age of the sauropods. That time has faded, leaving behind echoes of towering shapes that once grazed the upper branches of ancient forests. Now we find ourselves in a younger world where the air is still warm and alive, and new species have discovered the same elegant solution the old giants once used. Their silhouettes stretch upward, necks rising like living pillars of curiosity. One creature bends its head to browse from a cluster of high leaves, then lifts it again with slow grace. Its body is different from a sauropod. Its limbs do not resemble those ancient columns, yet the shape of its life tells the same story. The trees offer food in layers, and the creature's neck lengthens over generations, inch by inch, until the forest canopy becomes an open invitation. Reaching high vegetation is one of evolution's gentle shortcuts to abundance. On the forest floor, competition can be fierce. Many animals gather there, nibbling leaves and stems and soft shoots. But above, in the calm space between branches and sky, sunlight feeds leaves that smaller creatures cannot reach. These leaves are fresh, warm, and filled with energy from the light that touches them each day. Any animal that can lift its head into this quiet, elevated world gains a quiet advantage. Natural selection often follows this advantage with patient persistence. A slightly longer neck gives a creature more access to food. Those who can reach higher survive harsh seasons more easily. Those who survive pass on their traits. And over countless generations, necks stretch gently toward the sky, repeating a pattern established long before. We move through time again, passing into a world closer to our own. Here we find giraffes browsing among tall acacia trees. Their spotted coats glow softly under the sun. Their long legs and long necks sway with a rhythm shaped by centuries of wind through the savanna. They feed from branches that smaller animals can only look at. Their height lifts them into a separate layer of the ecosystem, a world of thorns, blossoms, and leaves brushed by warm light. Giraffes are not the only ones. Across different continents and eras, various herbivores evolve similar forms. Some resemble giant deer with stretched necks. Others grow elongated snouts and flexible upper lips to reach higher still. Even smaller mammals, in their own scale, experiment with reaching upward, standing on hind legs, or climbing trunks to access the canopy. The details differ, but the story remains the same. When food gathers in the air above the ground, life reaches for it. These giant browsers do more than feed, they shape their landscapes. Their movements prune branches, opening pockets of light that fall to the forest floor and nourish younger plants. Their browsing patterns determine which trees flourish and which remain small. Their height allows them to serve as architects of the spaces where they walk. The canopy bends gently to their presence. Each time the world stabilizes, each time forests spread and trees grow tall, the same ecological role becomes available again. A creature who reaches what others cannot. A creature who turns height into opportunity. This role is never truly empty. It disappears only when conditions change. But once the world warms and settles again, it returns, waiting for any lineage bold enough to stretch upward. Evolution does not plan these echoes. It simply responds to the quiet invitations the world offers. Forest canopies whisper of food beyond the reach of many. Sunlight gathers on high branches, leaves grow thick where rivals are few, and life, guided by the simple logic of survival, moves slowly toward the heights. We pause beneath one of these towering browsers as it lifts its head into the green shimmer of leaves. The forest holds its breath for a moment. The branches above sway gently. In the creature's long neck, we see memories of forms that once lived long before it, not inherited through blood, but shaped by the same gentle rules that the earth repeats whenever the chance appears. The canopy closes softly overhead. Light filters through the leaves, scattered like drifting gold. And in this quiet space, the pattern continues, rising toward the sky, in bodies shaped by time and steady opportunity. As the tall silhouettes of the great browsers fade into the warm light of the forest, the world around us shifts once more. The trees thin, opening into wide meadows and cool valleys shaped by rivers that move with slow confidence. Here, the air carries hints of distant storms and the earthy scent of soil that has known many ages. It is in this kind of landscape, open and uncertain, that another recurring pattern begins to rise. Not a grazer, not a specialist, but a creature shaped by adaptability itself. These are the giant omnivores. Their story is quieter than that of the towering sauropods or the soaring giants of the sky, yet their presence is just as deeply rooted in the logic of survival. They appear in different forms across distant ages. Bears in northern forests and mountain ranges, massive marsupials in Australia's ancient plains. Each has its own lineage, its own history, its own place in time. Yet they converge on a similar truth. When the world becomes unpredictable, when food sources shift or dwindle or scatter, the creatures that can eat many things often become the ones that grow largest. We walk first into a forest where tall pines sway gently in the wind. The ground is soft beneath our feet, carpeted in fallen needles. A large shape moves through the trees, steady and silent. A bear steps into view, its fur catching the muted light as it sniffs the air. Its body is powerful but not hurried. This giant can find food in many places: berries in summer, roots in early spring, fish that leap through cold rivers, small animals that hide in dens beneath the snow. It does not rely on any one food source alone. Omnivory gives this creature a kind of quiet stability. When a harsh season comes, when rains fail, when ice lingers longer than expected, it can shift its diet with ease. It is this flexibility that invites size. A body that can digest many kinds of food does not need the perfect environment. It only needs enough opportunities, spread across different seasons, to grow and thrive. Over countless generations, this steady access to varied resources allows large omnivores to rise, their forms shaped by the changing rhythms of the land. We drift through time again, carried gently across continents and ages. The world around us becomes warmer, then drier. Rivers wind through wide open plains, where tall grasses ripple under soft sunlight. In this landscape stands a creature that resembles a giant wombat, though its size and strength far exceed anything familiar to us. This is one of the great marsupial omnivores that once roamed Australia, their bodies shaped by the challenges of a land known for both abundance and sudden scarcity. These marsupials lived in environments that shifted quickly. Some years brought heavy rains and food that grew in thick clusters. Other years offered little, leaving the land dry and pale. A specialist would struggle here, but a generalist, a creature that could feed on plants, fruit, insects, small animals, and whatever else it could find, became a quiet master of survival. As generations passed, bodies grew larger. Larger bodies hold energy more efficiently. They move farther. They store fat for lean times. They become both resilient and influential in their ecosystems. Omnivory is a gentle path toward gigantism because it spreads risk. A creature that eats many things is less vulnerable to sudden changes. When forests burn, it can forage on new growth. When droughts dry the rivers, it can search for roots or hunt smaller prey. This freedom reduces the constant pressure that keeps most animals small. When the fear of starvation lessens, evolution can invest in size, and when size arrives, it offers its own advantages. Large omnivores become apex creatures not because they are the most aggressive, but because their bodies carry the quiet strength to defend themselves and their young. Their presence shapes the movements of smaller animals. Their foraging patterns carve paths in forests, open spaces in tall grasses, and scatter seeds across long distances. They do not rule through dominance, but through presence and persistence. We continue wandering through different eras, watching giant omnivores rise where conditions allow. Each time, the world shares a similar story: unpredictable climates, mixed landscapes, seasons that vary in strength and length. These are places where flexibility becomes more important than specialization, and so the giants rise again, their bodies built not from a single food source, but from many. In the stillness of this moment, we stand beside one of these immense creatures. Its breath leaves faint clouds in the cool air. Its eyes move slowly, scanning the world with a calm awareness shaped by thousands of years of adaptation. It does not hurry. It does not need to. The land offers different meals in every direction, and its body knows how to use them all. Eventually, the creature moves on, disappearing into the tall grasses with the same gentle confidence with which it arrived. The quiet settles again. The landscape stretches before us, shaped by the footsteps of omnivores who have come and gone across ages. The echo remains soft and steady. Wherever the earth creates a world of shifting food and unpredictable seasons, giant omnivores rise, guided by the simple wisdom of eating whatever the land provides. As the giant omnivores fade into the grasses, the world shifts once more. The ground beneath us softens, the horizon narrows, and far in the distance we see the outline of something new. Water surrounds us again, though not in the endless vastness of ancient oceans. Instead, we drift toward smaller worlds, scattered like quiet thoughts across the surface of the sea, islands, each one separated by shimmering waves, each one holding its own set of rules, and each one telling its own gentle story about how life grows when the rest of the world is far away. Islands are strange and tender places. Their boundaries are firm and unchanging. Their ecosystems form like slow breath, rising and falling with the tides, the storms, and the rhythms of birds that arrive by accident or intention. On these isolated lands, evolution moves differently. It grows cautious, then bold. It stretches in unexpected directions. Without the constant pressure of large predators, without the competition found on vast continents, small creatures begin to change. They explore sizes and shapes that would never be possible in crowded worlds. This is where island gigantism begins. We land on a quiet shore. The light feels softer here. The trees sway in gentle breezes that carry the smell of salt. And moving through the greenery, we find creatures that seem familiar yet strangely enlarged. A bird steps into the open, its feet pressing softly into the moss. It is far larger than its mainland cousins, with feathers that shimmer faintly in the filtered sun. In the absence of predators, flight becomes unnecessary. Energy spent on wings becomes energy spent on size. Over countless generations, a small bird becomes a giant walker of the forest floor. Islands invite growth in this way. When threats disappear, size becomes a comfortable strategy. Large bodies offer many advantages. They retain heat, they reach more food, they survive seasonal changes more easily. They live longer, allowing slow and steady reproduction to flourish. Without predators, the need for speed or stealth slips quietly away. What remains is the simple opportunity to expand. We wander deeper, and the shadows between the trees thicken. A rustling sound comes from a nearby thicket. A large reptile emerges, its scales catching the dim light. It resembles a lizard, but its size suggests something far older. This, too, is a child of island isolation. Many times in deep history, reptiles have grown into giants on islands because nothing there kept them small. Without fierce hunters to limit their spread, without competition from large mammals, they rise steadily into forms that dominate their small worlds. Rodents follow the same path. A creature that scurries beneath leaves on the mainland becomes something altogether different on an island. Over generations, it grows heavier, its bones thicken, its steps become deliberate. It feeds from trees, shrubs, and grasses that once lay beyond its reach. Large rodents become the quiet gardeners of isolated ecosystems, shaping the undergrowth through their feeding habits, carving trails through the vegetation, altering the forest forms tile by tile. Each of these examples grows from the same simple truth. Islands offer stability, not perfection, not ease, but consistency. The seasons repeat in familiar patterns. Food sources remain steady, even if limited in variety. Without the constant threat of predators, slow and large can thrive, as well as swift and small. And in that freedom, gigantism becomes a repeated solution. As we explore one island after another, we notice the subtle differences between them. Some islands grow giant birds that move like shadows through the dim understory. Others develop enormous tortoises with shells that shine under soft light. Some become home to giant rats, gentle in their movements and shaped by the rhythm of low competition. The variations are endless, but the pattern behind them remains calm and clear. Isolation gives evolution a quiet canvas. In the mainland world, predators shape bodies through constant pressure. Prey must stay small and quick. Herbivores must hide or flee. But on islands, the canvas changes. When the threat of being hunted vanishes, the need to remain small disappears. Bodies grow in the direction of abundance, not fear. Large size also helps creatures travel longer distances within their small territory. It allows them to store food in their bodies during dry months. It helps them reach new sources of vegetation when the land shifts or storms reshape their forests. In these ways, gigantism becomes less about dominance and more about endurance. We pause at the edge of a high cliff overlooking the sea. Waves break gently below, sending pale mist into the air. On the ridge behind us, a giant bird moves with slow certainty, its footsteps echoing faintly in the quiet dawn. Its wings are reduced to feathered stubs. Its eyes watch the world with calm confidence. It is a creature that could exist only here, in a world where the greatest dangers have always been the storms, the seasons, and the passing of time. As the light softens around us, we look across the islands scattered through the distance. Each one carries a different echo of evolution, yet all share the same quiet story. When the world shrinks into a small circle of land, life is free to grow in ways that the mainland rarely allows. The islands hold their breath, the waves shimmer, and the giants, once small, walk gently through their isolated worlds, shaped by the calm rules of places set apart from time. As the quiet islands fall behind us, the world expands once more into a broad tapestry of continents, seas, forests, and skies that stretch into the distance like a slow unfolding dream. Yet something deeper than landscape begins to change now. The air itself shifts around us. It thickens, then thins. It grows rich, then sparse. These changes happen slowly, over spans of time so long that even mountains rise and crumble before they finish. And with each shift in the atmosphere, the limits of what life can become are rewritten. Oxygen, the familiar breath that fills our lungs, has not always existed in the same amounts. It rises and falls in long, gentle cycles. Sometimes the air carries only a small trace of it, just enough for small creatures to survive. Other times, the planet becomes flooded with oxygen, and the world responds with a quiet, astonishing transformation. Bodies grow larger. Movement becomes more powerful. Entire ecosystems swell with the possibility of size that was never possible before. We begin far back in the ancient Paleozoic, when oxygen levels rise to heights the modern world no longer knows. The forests of this era are dense and humid, filled with towering plants that feed the air with more oxygen than future ages would ever hold. As we walk through these shadowed groves, the air feels thick with potential, like a warm breath held for too long. The creatures here carry forms shaped directly by this atmospheric abundance. In the branches above, an enormous insect shifts its wings, sending a soft rustle through the canopy. It is a dragonfly-like creature, yet its wings stretch wider than the span of our arms. Its body rises with gentle effort, buoyed by air rich enough to sustain muscles that would be too heavy in later ages. Giant millipedes, thicker than tree branches, coil slowly across the forest floor. Their segments glisten in the filtered light. They breathe through tiny openings along their bodies, a method that limits size in low oxygen worlds. But here, where oxygen saturates every corner of the air, they grow larger than any future arthropod could dream. These giants exist because the atmosphere allows them to. The air becomes more than background. It becomes a gentle engine that powers growth. Every breath carries more fuel. Every movement becomes easier. Oxygen shapes the boundaries of life without ever lifting a finger. But the world shifts again. As oxygen levels fall in later eras, the insect giants disappear. Their breathing systems, once perfectly matched to the air, can no longer support such size. Forests change, climates change, and with those changes, gigantism becomes impossible for creatures that depend directly on the oxygen content of the atmosphere. They shrink, adapting to new limits written into the very air around them. We drift forward into another era. Long after those towering insects have vanished, the seas become the stage once more. Oxygen levels begin to climb again, though never to the extremes of the ancient forests. In these oceans, early fish find themselves in a world with richer oxygen stores. Their bodies metabolize more efficiently, muscles grow stronger, predators become larger, faster, more capable of long pursuits. In times when the seas are especially productive, when oxygen and nutrients rise together, marine giants appear. Some are hunters, some are filter feeders. All owe part of their size to the atmosphere above them, whose oxygen slips quietly into the waves. Even on land, the atmosphere continues to leave its mark. In eras when oxygen rises, large herbivores flourish more easily. Their bodies require vast amounts of energy to support their weight, and oxygen-rich air helps them process food with greater efficiency. Lungs draw in more with each breath. Blood carries more with each beat. When the air becomes especially generous, the land grows giants with surprising ease. When the air thins again, those giants struggle. Some vanish, others shrink. The cycle repeats as gently as the turning tides. We walk now into a world closer to our own, where oxygen levels settle into a more familiar balance. Here, the atmosphere supports large mammals, though none reach the extreme sizes possible in distant eras. Elephants roam through warm grasses, giant marsupials rise on isolated continents, enormous flightless birds stride across open plains. Each of these shapes exists within the limits written by the current atmosphere. They reach impressive sizes, but never beyond the boundaries imposed by the air they breathe. Throughout Earth's history, oxygen has acted like a quiet craftsman. It has built eras of giants, then gently ushered them away. It has allowed insects to take to the air with enormous wings, then limited them to the small forms we know today. It has shaped oceans full of massive hunters and peaceful filter feeders. It has created windows of opportunity where gigantism is suddenly possible, if only for a panther, while the air around us now feels calm and steady. Sunlight warms it. Wind carries it gently across the land. Its oxygen content is modest compared to the ancient peaks, but balanced enough to support the great variety of life around us. We breathe it in and out, just as the world does. And in this breath lies the memory of all the giants that rose when the air allowed them to, and faded when the atmosphere changed its tune. For a moment, we pause and let the air settle softly against our skin. It carries the quiet story of Earth's shifting possibilities, written not in stone, but in the invisible substance that fills every moment of every life that ever lived. As we leave behind the shifting atmosphere of Earth's ancient ages, the world settles into a quiet stillness. We stand in a place where time feels soft, as though the planet is offering a pause before the next chapter unfolds. Around us, the elements of Earth whisper their steady truths: water, air, soil. They seem simple, yet each holds invisible rules that shape the bodies of every creature who dares to grow large. Life, for all its creativity, is never free from physics. Every giant that has walked, flown, or swum through Earth's long history has been shaped as much by physical forces as by evolution itself. These forces act gently but relentlessly. They do not command, but they limit. They do not design, but they guide. And through their quiet insistence, they push life toward the same shapes again and again. We begin by stepping into water. The ocean surrounds us with a cool embrace, carrying weight that supports but also resists. In these depths, movement becomes a negotiation. A body must push aside the water that fills every space. Drag appears as a soft but constant pull, slowing anything that tries to move too quickly. A creature shaped like a jagged stone wastes precious energy with every stroke. But a creature shaped like a teardrop slides through the water with ease. This is why so many marine giants, from ichthyosaurs to dolphins to ancient fish, carry the same smooth silhouette. Water rewards any shape that allows it to part cleanly, then rejoin without turbulence. Rounded fronts, narrow middles, tapered tails. These forms are not coincidences. They are answers to the same question asked across millions of years. How do you move through water without losing strength to drag? Buoyancy adds another rule. Water lifts heavy bodies, allowing giants to grow without collapsing under their own weight. But it also demands balance. A body too dense sinks. A body too light rises against its will. So the ocean shapes its giants with careful distribution of mass and air. Bladders in fish, lungs repurposed as flotation devices in certain reptiles, fat deposits in modern whales that help them float and stay warm. Nothing exists by accident. Every giant is a quiet conversation between organism and water. When we rise from the ocean and feel air brush against our skin, the world shifts. Air carries far less resistance than water. Here, movement feels light and unburdened, but the ease of moving through air brings its own challenges. To fly, a creature must create lift. Lift forms when air flows across wings shaped just right: a broad surface, a subtle curve, a leading edge that parts the air. These simple features appear again and again in flying giants because physics offers only a few solutions. Even the largest flyers of all time, from pterosaurs to giant birds, had to obey these limits. Their wings could not be too heavy. Their bones could not be too thick. Their bodies could not grow larger than the air could support. When Earth's air grew thinner in certain eras, flight itself became more difficult. The largest flyers vanished, replaced by smaller ones who needed less lift. On land, gravity becomes the great sculptor. Every giant must support its own weight, and this rule is unforgiving. A creature's bones must grow thicker as its body grows larger. Muscles must expand. Ligaments must strengthen. There is a point beyond which weight becomes too much for bone and tissue to bear. This is why the largest land animals, across eras, share similar features. They walk with straight legs that hold their bodies like pillars. Their feet spread wide to distribute pressure. Their strides are steady and slow, conserving energy. Their torsos are broad to house organs large enough to feed and fuel immense bodies. And their necks, if long, counterbalance their tails or hips to keep their center of gravity stable. These traits emerge not from shared ancestry, but from shared physics. It is the land itself that shapes these creatures into familiar forms. An animal that grows too large must either find ways to support its weight or shrink. Evolution may experiment, but the earth always decides. Drag, lift, weight, and buoyancy are simple words for forces that shape the destiny of life. Each force gently restricts what is possible, reminding evolution that creativity has boundaries. The ocean asks for streamlined shapes. The sky demands wide wings and light bodies. The land requires sturdy bones and careful balance. These forces explain why giants across history look strangely alike, even when they are separated by time, lineage, and origin. The world offers only a few viable forms that can carry great size, and so the same patterns return. Streamlined bodies slicing through water, enormous wings stretching across air, towering legs supporting massive frames on land. We stand in the soft quiet of these truths. The world around us feels calm, as if held in a gentle equilibrium shaped by forces we cannot see but always feel. In this stillness, we understand that evolution repeats itself not from memory, but from constraint. The physical laws of Earth guide life toward what works and away from what does not. And in this long dialogue between physics and biology, the forms of giants reappear like familiar melodies carried through the changing ages. As the quiet laws of physics settle around us, the world begins to shift once more. The air cools, the ground trembles. The soft rhythm of distant waves grows louder, then fades. We step into a moment of deep transformation, one that repeats itself throughout Earth's long story. For every era shaped by thriving ecosystems and familiar giants, there comes a moment when life is swept clean. Mass extinctions move through the world like slow, catastrophic storms. They erase, reshape, and silence entire lineages. Yet within that silence, something new always begins. We find ourselves standing on a landscape emptied of its former rulers. The sky feels wider, the forests thinner, the oceans quieter. The earth is in one of its great pauses, a breath taken after destruction. In this fragile stillness, small creatures move cautiously. They pick through the remains of a world that vanished almost overnight. They do not know the scale of what came before them. They only know the emptiness that a power by now surrounds them. This is the reset effect. A mass extinction does more than remove life. It erases the balance of power. It dissolves the intricate webs that once held ecosystems together. Apex predators disappear along with their prey. Mid-sized animals vanish. The smallest ones often survive, but with no large hunters above them, they move through an unfamiliar world. As they feed, scatter, and survive, they unknowingly prepare the ground for something larger to rise again. Evolution does not grow giants in times of chaos. It grows them in the quiet that follows. When the world is still recovering, when competition is low, when available roles lie empty like open rooms in an abandoned house, lineages that were once small begin to explore new shapes. We walk through this recovering world, watching as tiny survivors multiply. Their populations swell in the absence of predators. Some remain small, others grow larger as their bodies adjust to new opportunities. Slow changes accumulate like silt in a riverbed, layer upon layer. Over millions of years, new predators emerge from unexpected places. In one age, reptiles rise again to claim the oceans after earlier hunters have vanished. In another, mammals step into the shadow of ancient giants and discover strength they never needed before. In yet another, fish take advantage of newly opened seas, their lineages stretching into forms that grow heavy with armor and power. The specifics differ, but the rhythm remains the same. Extinction clears the stage, evolution auditions new players, and eventually, a giant predator rises to fill the emptiness. We drift into a world where early mammals are beginning to expand after the extinction that ended the age of the dinosaurs. The land is warm, forests spread, the oceans teem with small fish and squid. Nothing here resembles the massive reptilian hunters that once dominated. Yet as we walk across the continents, we notice something subtle. Certain mammals begin to combly grow larger heads, stronger jaws, and bodies built for pursuit. Their prey is plentiful, the land is stable, the role of apex predator lies open. Over time, these traits deepen, shaping animals that rule their environments with a calm and quiet authority. Further ahead, in oceans newly freed from ancient reptilian dominance, sharks begin a similar transformation. The predators that once challenged them have vanished. Food is abundant. Waters rich with plankton feed smaller fish, which feed medium fish, which eventually grow large enough to support giants. Without competition from old lineages, sharks expand into bodies that slice through open water with effortless strength. They become immense without ever needing to outmatch their ancient rivals. The world itself makes space for them. Each time this happens, evolution restarts its arms race. Prey animals grow faster, stronger, more aware. Predators respond, jaws sharpen, limbs strengthen, bodies streamline. The quiet arms race unfolds not as a battle, but as a slow conversation, a back and forth shaping that spans millions of years, guided by necessity rather than intention. And yet, no matter where we stand in time, the apex role always returns. It does not belong to any one lineage. It is a place within the ecosystem that life refills as soon as the world stabilizes. Because somewhere, once plants spread and herbivores flourish, there is always room for a creature strong enough to keep that balance in check. We stand now at the edge of a vast plain. The evening light softens the land. In the distance, a large carnivore steps forward, its silhouette calm and certain. It belongs to a lineage that had once been small, a lineage that survived in the shadows of older giants. Now, with the old world gone, it has found its moment. Its size is not a memory of the past. It is a response to the present. The world needed an apex hunter. Evolution offered this shape. For a moment, the creature lifts its head. The wind brushes through the grass. Quiet settles around us like a long exhale. The reset is complete. The arms race has begun again. The role of giant predator, erased by catastrophe, has returned in a new form shaped by the same gentle logic that guides all life. The earth turns, the world rebuilds, and once more, the giants rise. The world settles after the Great Reset, and we move forward into a new rhythm shaped not by single events, but by the long breathing of the planet itself. Earth, through its vast history, has shifted between different moods. Some ages are warm and lush, carrying thick forests and deep blue seas that shimmer with life. Others are cold and quiet, wrapped in ice that stretches across continents. These alternating moods, greenhouse and icehouse, guide evolution with a patience that spans hundreds of millions of years. We find ourselves standing at the edge of a quiet plain as warm sunlight spills across the ground. The air carries the scent of pollen and distant rain. This is a greenhouse world, one of Earth's long, warm phases. In these eras, the climate becomes stable for long stretches of time. Winters grow mild, summers linger, food spreads widely across the continents, lakes fill with life, forests rise tall and thick. Warmth wraps the land like a soft blanket. In such worlds, giants find room to grow. Warm climates support abundant plants, and plants support the bodies of creatures who feed on them. When vegetation stretches far across the land, herbivores can wander long distances without fear of hunger. A large body becomes a quiet advantage. It stores heat, it travels far, it digests slowly and efficiently. Stability welcomes them, and evolution responds by shaping animals that rise taller, grow broader, and move with the calm confidence of creatures who do not fear scarcity. The oceans too swell with rich life during greenhouse periods. Warm currents blend nutrients in gentle spirals. Plankton blooms spread across the water's surface. Small fish gather, then larger ones, and soon the seas are filled with possibilities. Marine giants appear in these eras, their bodies shaped by abundant food and the soft push of warm ocean currents. Filter feeders grow enormous. Predators expand into powerful forms that glide across wide waters. We drift through this warm world, watching these creatures thrive. Then, slowly, the warmth changes. It fades not all at once, but in a long, steady cooling that touches the forests first. Trees that once reached toward the sun begin to retreat. Grasses spread across the land. Snow appears at the edges of mountains. The air grows thinner, crisper. Earth begins its shift into an icehouse phase. Icehouse worlds are colder, sharper, and harsher. Large animals require more energy to stay warm, and food becomes limited. Winters stretch longer, summers shorten. The land tightens its grip on resources. In these colder eras, giants often struggle. They do not vanish entirely, but they become fewer and more selective about where they live. Large bodies lose heat more slowly, but they require steady food, and icehouse worlds rarely offer that. Across the Phanerozoic, the vast stretch of time covering the last 540 million years, these cycles repeat. Warm ages build giants, cold ages whisper them away. We step through time now, watching the pattern unfold like gentle waves. In the early Paleozoic, warmth spreads through the seas. Giant cephalopods rise, drifting through soft blue waters. Their size is supported by oceans filled with nutrients and sunlight. Later, during the Mesozoic greenhouse world, forests stretch across supercontinents. The air is warm and rich. Sauropods reach their magnificent sizes, walking through lush plains and forests where food was plentiful. Pterosaurs rediscover the sky in enormous forms, lifted by warm winds and dense air. Oceans fill with ichthyosaurs and pliosaurs, shaped by abundant life and stable climates. Then the earth cools again. Ice clings to the poles, sea levels drop, forests shrink, the giant reptiles vanish. Smaller creatures fill the cooling world, adapting quickly to the shifting climate. Warmth returns in the early Cenozoic. Rainforests spread across continents. New mammals begin to grow larger. Elephants, ground sloths, and descas. Rhinoceros-like forms rise through warm valleys and plains where food stretches across the horizon. The oceans fill with whales larger than anything that came before, carried by water rich in nutrients and stirred by warm currents. Later, another cooling begins. Ice sheets expand. Grasslands replace tropical forests. Many giants fade once more. Only certain ones remain, surviving in pockets where conditions still allow size to flourish. These cycles do not erase the pattern. Instead, they reveal its gentle logic. When the world warms, life grows upward and outward. When the world cools, life turns inward, becoming smaller, quicker, and more flexible. Throughout all of Earth's long story, climate has acted as a quiet rhythm, guiding the rise and fall of giants. Evolution does not force gigantism, the planet invites it. Whenever warmth spreads evenly and food becomes stable, the path toward size appears. Whenever cold tightens around the world, that path narrows. We stand at the boundary of one of these ancient transitions. Warm sunlight fades into cool evening. The last glow reflects across the land, carrying with it the memory of all the giants who grew under gentle skies. It is a soft reminder that Earth's story is written not only through creatures, but through the breath of the planet itself. The world exhales its quiet warmth as we move forward from the long cycles of climate. Light settles gently over the land, and we find ourselves wandering through a place shaped not by size alone, but by caution. The ground here carries faint patterns of movement, soft tracks pressed into soil, marks left by claws, trails carved by heavy feet. Something in this landscape speaks of tension, of survival balanced carefully against danger. This is a world where armor finds its meaning. Armor is one of evolution's oldest ideas, yet it is never the same twice. Different lineages discover it in their own ways, shaped by the threats and possibilities of their time. Some grow plates of bone beneath their skin, others weave keratin into rigid shells. Some carry spikes that glint in sunlight. Some carry shields as smooth as polished stone. And each time, armor appears not as a decoration, but as an answer to the same ancient question. How does a creature endure when predators grow powerful? We step into the deep past first, into a world where great dinosaurs walk across warm plains. Tall ferns sway in the breeze. Distant volcanic slopes smolder with a dull glow. And moving slowly through the vegetation is the silhouette of an ankylosaur. Its body is broad and low, supported by stout legs that press softly into the earth. Its back is covered in plates of hardened bone, arranged like tiles in a mosaic. Along its sides, spikes jut outward, shaped like frozen waves. At the end of its tail rests a heavy club, lifted now and then with gentle swaying motion. The ankylosaur is not built for speed. Its strength lies in endurance. Predators roam these plains as well, fierce and agile, but the ankylosaur carries a shield that no teeth can easily pierce. Its armor turns its entire body into a quiet fortress. It moves through the world with deliberate calm, grazing on low plants, trusting in the strength of the plates that have grown from generations of survival. This is the first great expression of armor in our journey, but far from the last. Time shifts around us. Forests fade, seas rise and fall, dinosaurs vanish, and new lineages step into the open spaces they leave behind. We walk into a younger world, one filled with mammals shaped by landscapes now familiar to us. Grasses stretch to the horizon. Rivers move slowly across broad floodplains. And there, grazing near the water's edge, we see the rounded form of a glyptodont. It looks like a giant armadillo, but heavier, broader, and wrapped in a dome of interlocking plates fused into a single shield. Its shell curves over its back like a smooth stone warmed by the sun. Some glyptodonts carry spiked tails. Others carry shells adorned with ridges and patterns that resemble intricate carvings. Their armor emerges from the same quiet logic that once shaped the ankylosaurs, though the two lineages are separated by millions of years and entirely different origins. The glyptodonts live in a world where predators have grown strong again. Saber-toothed cats stalk the tall grasses. Large birds hunt from above. Wolves move in packs. Armor reappears because the ancient cycle of predation has returned. Once more, being slow can still be safe, As long as the body is well defended, we wander onward through time, watching the land shift into an even more recent age. The environments begin to resemble corners of the world we know today. In the warm regions of the Americas, smaller armored mammals move through forests and scrublands. These are modern armadillos, distant relatives of the glyptodonts, carrying the last echoes of that great armored tradition. Their shells are lighter, flexible in places, allowing them to tuck into burrows and escape danger. They feed on insects, plants, and small creatures they uncover in soft soil. Though far smaller than their ancient cousins, their armor serves the same purpose, a shield between them and the unpredictable world around them. And as we move through these eras, we begin to see the deeper pattern behind armor's repeated reinvention. Predation is not constant, it rises and falls in cycles. At times, predators dominate, growing larger, faster, and more coordinated in their hunts. In those moments, prey must find ways to protect themselves. Some flee, some hide, some grow sharp senses, but others choose the ancient path. They build walls around their bodies. When predators become too powerful, armor becomes a refuge. But when the world shifts again, when climates change or extinction resets the balance, predators fade, and in those moments, armor becomes unnecessary. The weight of plates slows movement. The energy needed to grow them becomes costly. Many armored lineages shrink, transform, or disappear. Later, when predators rise once more to dominance, armor reappears in new bodies shaped by new environments. It is a slow dance. The world pulses between danger and calm. Evolution answers with shields each time danger grows too sharp. We pause. Now, in a quiet clearing, where sunlight falls gently onto the earth, an armadillo rustles through leaves. Its small armored shape glimmers softly, like a distant echo of the plates worn by creatures long gone. Its movements are simple, careful, unhurried, yet within its domed shell lies the memory of a pattern repeated countless times. Armor appears when the world demands it. It fades when the world allows it. Then, in another age, under different skies, it rises again. The land grows quiet around us. A soft wind brushes past, and the ancient rhythm of danger and protection settles into the stillness, ready to shape whatever creatures come next. The world quiets again as we step away from the lands of armored creatures. The air grows heavier, warmer, and rich with the scent of damp soil. It feels as if we have wandered into a dream where the air itself carries more weight than we remember. Sunlight filters through towering plants that are neither trees nor shrubs, but ancient forms that stretch toward the sky with delicate fronds. This is the Carboniferous world, a time when the air held far more oxygen than it does today, and a time when insects grew to sizes that seem almost unreal to us now. We move carefully through the dense forest, our footsteps softened by layers of fallen leaves that have accumulated over many seasons. The air feels thick with humidity. Each breath seems to cling to our skin. The plants rise in tall columns, their trunks smooth and patterned with lined scars. Vines curl upward in slow spirals. Pools of shallow water reflect the filtered light. This world is lush, warm, and vibrant, shaped by a climate that encourages life to grow freely. A faint fluttering sound echoes above us. When we look up, a shadow passes across the canopy. It belongs to a creature that feels like a memory from a distant bedtime story. A dragonfly-like insect glides through the air, its wings stretching wider than a human arm span. The shimmering patterns on its wings catch bits of sunlight as it weaves between the tall plants. It lands for a moment on a broad leaf, revealing a long body lined with delicate segments that glow softly in the damp air. Nearby, a giant millipede inches its way across the forest floor. Its body is thick as a log, its many legs moving in a smooth wave that rolls gently from head to tail. It pauses near a fallen trunk, tasting the moist wood with its small, simple mouth parts. There is no hurry in its movement. In this world, size comes easily. These insects and arthropods owe their astonishing forms to a simple yet powerful force: the atmosphere. During the Carboniferous era, oxygen levels were far higher than they are today. This abundance allowed creatures that breathe through small openings along their bodies to grow far larger than modern insects. Their breathing system, based on passive diffusion rather than lungs or active pumping, becomes more efficient when oxygen is plentiful. As oxygen soaked through the air and into their tissues, these ancient arthropods stretched into forms that no longer exist. Yet this period of abundance was not eternal. Earth shifted its mood. Climate changed. The composition of the atmosphere changed with it. As oxygen slowly decreased, the giants of the Carboniferous forests began to shrink. Their bodies relied on high oxygen levels to function at large sizes. Without this support, their breathing systems could no longer fuel such immense frames. Over time, the great dragonflies and towering millipedes faded into smaller forms, adapting quietly to the new limitations of the world. But gigantism did not disappear forever. To step through time again, moving past the Carboniferous forests into eras when insects had already become smaller. The forests change shape, the plants grow different leaves, the ground becomes drier in places. Yet here and there, through different periods, new arthropod giants arise. None reach the sizes of the Carboniferous creatures, but some grow impressively large compared to their ancestors. Giant sea scorpions hunt in shallow waters. Large terrestrial arthropods appear in certain niches. Their bodies, while smaller than the Carboniferous giants, echo the same possibilities. These repeated appearances are shaped by the same quiet forces. Oxygen rises modestly in some eras, allowing certain arthropods to stretch toward their former potential. In other periods, the absence of large predators creates a moment when size becomes advantageous again. But these windows are brief. Oxygen levels never return to their ancient peak. Life continues to shift. And so, the giants of later ages remain shadows of their Carboniferous predecessors. Eventually, the world enters an age where oxygen levels settle into a familiar balance. This balance supports a rich variety of insects, but it sets strict limits on how large they can grow. Modern insects remain small not because evolution forgot how to build giants, but because the physics of breathing through tiny openings restrict what their bodies can do in a world with lower oxygen. Wings cannot grow too wide. Bodies cannot grow too thick. Air simply cannot deliver enough fuel to sustain such size. Predators also reshape the world. Birds, mammals, amphibians, reptiles, and other skilled hunters rise into ecosystems that demand agility, intelligence, and speed. Large insects would struggle to escape these predators. Smaller bodies become safer, faster, and more adaptable. Evolution follows the path that works best. In this quiet moment, we stand in a forest where modern insects hum softly around us. None stretch into the sky, like ancient dragonflies. None roll across the ground like giant millipedes. Yet within their small bodies lies a long history shaped by air, by climate, and by the delicate constraints of breathing. The giants came twice. They left no descendants of their size, but they left a whisper of possibility, a reminder that life grows to the edge of what the planet allows, then settles back when the world changes its breath. The world grows dim as we leave behind the forests and shallow seas of earlier ages. Light fades softly, step by step, until the sky above dissolves into a deep twilight. A cool wind brushes past, carrying the scent of salt and something older, something untouched by the warmth of the sun. Ahead of us, the ocean stretches wide and calm. Beneath its surface lies a world where sunlight cannot reach, a realm shaped not by seasons or storms, but by pressure, darkness, and time. We move gently into this water, letting the surface close above us like a second sky. The light around us thins, colors fade, the water grows colder. With every meter we descend, the world becomes quieter, as if sound itself is swallowed by the weight of the deep. In this stillness, life takes on strange and familiar shapes: long bodies, wide eyes, slow movements. And here, in places where darkness lasts forever, giants return in forms that echo across eras. A soft flicker of movement appears ahead, a shape drifts through the water, pale and graceful. It is a giant amphipod, its legs stretching like delicate branches. Its body is far larger than the tiny crustaceans we see near the shore. Here, where pressure grows immense and sunlight never shines, these small relatives become giants by deep-sea standards. They float with unhurried confidence, their bodies adapted to a world where speed offers no advantage, but endurance means survival. Nearby, an enormous isopod crawls slowly across the seafloor. It resembles an oversized version of the familiar woodlouse found in gardens, but stretched into a creature that spans the length of a human forearm. Its armored segments gleam faintly in the filtered darkness, catching the glow of bioluminescent specks drifting through the water. It pauses near a fallen piece of organic debris, exploring gently with its antennae. Food is rare here, but it does not need much. Its metabolism burns slowly, its movements conserve energy. Time stretches differently in the time stone, deep, and the isopod moves in harmony with it. Far above the seafloor, but still deep in the twilight zone, a shadow glides with silent power. A squid, long and elegant, moves with slow pulses of its mantle. Its eyes shine like small moons in the darkness. Some squids from these depths grow far larger, their tentacles trailing into the dark like drifting ribbons. These giants are built for endurance, able to travel long distances through cold waters that never warm with the sun. The deep sea creates giants because the rules here are different from those of the surface world. Pressure increases with depth, pressing on every body that tries to survive. Water here is cold, slowing the metabolism of all creatures that live within it. Food sinks from the surface in small, scattered pieces. Nothing arrives with regularity, and yet, within these challenges, a quiet opportunity emerges. Large bodies lose heat more slowly than small ones. They move with greater efficiency through still water. They can store energy during long periods between meals. And in a world where the greatest threat is not a predator but the simple lack of food, size becomes a gentle advantage. Oxygen also plays its part. Deep water often holds more oxygen than surface water, cooled and enriched as it sinks from polar regions. Creatures here breathe slowly, drawing in this abundance at a calm pace that matches their slow lives. With more oxygen available per unit volume, their tissues support larger forms without strain. Their metabolisms burn with soft steadiness, shaped by a balance between pressure and patience. But perhaps the most important factor is time. Life in the deep moves slowly. Growth takes longer. Movements are measured. Events unfold over years rather than moments. This slow rhythm encourages lineages to drift gradually toward larger forms. There is no rush to escape predators. There is no need for quick bursts of energy. The deep rewards the steady and the efficient. And over countless generations, efficiency guides bodies toward size. We watch as another amphipod floats by, its pale body glowing gently in the dimness. Behind it, we see the faint outline of a larger silhouette, perhaps a squid moving with long, sweeping motions. Each one seems shaped by the same quiet conditions, though they come from different branches of the tree of life. The echo is unmistakable. The deep sea grows giants again and again, repeating the pattern with calm, unhurried certainty. As we sink gently toward the seafloor, the pressure presses around us like a steady embrace. The darkness feels complete, yet life continues. It pulses through the water in small flashes, soft movements, drifting forms. The giants here are not fierce or fast, they are patient. Their size is a whisper of the world they inhabit. Eventually, we rise back toward the light, leaving the deep in its perpetual night. As we ascend, the water warms, colors return, the shapes of surface life grow sharper and axis more familiar, yet the memory of the deep remains with us, a place where the rules soften, where life slows, where giants return not through power, but through the gentle logic of endurance. The deep sea holds its secrets close, but the giants that move through its darkness offer a glimpse of how life grows when pressure, oxygen, and time unfold together in a long, steady circle. As the deep sea fades around us and the weight of the water loosens from our shoulders, we rise gently into a world shaped not only by climate or physics, but by the quiet needs of life itself. The earth settles into a soft and balanced breath. Grasslands ripple in long waves. Rivers weave through valleys in slow silver lines. Forests sway with layered leaves, whispering to one another in the wind. In this balanced world, something subtle begins to appear, a pattern that threads through every ecosystem on the planet. Life creates spaces, and in these spaces, certain roles always return. These roles are not assigned, and no creature chooses them deliberately. They are simply ways of living that emerge whenever plants, water, sunlight, and other organisms share a place. They are quiet invitations offered by nature, and evolution accepts them again and again, using different species each time to fill the same ancient needs. Some roles require speed, some require agility, but a few invite giants. We walk into a broad open plain where the air feels warm and steady. The grasses sway gently at our knees. In the distance, we see tall shapes moving slowly, their silhouettes stepping carefully across the land. These creatures are browsers, those who feed high or low, shaping the vegetation with each slow bite. Their forms vary across time. Sometimes they are sauropods, sometimes elephants, sometimes towering mammals now long gone. But the role remains constant. The land offers plants. The plants grow tall or thick, and somewhere, inevitably, a giant arises to eat them. Browsers are not giants, because evolution favors size for its own sake. They grow large because the role of a browser demands it. A large herbivore can reach more leaves. It can travel long distances in search of new patches of vegetation. It can carry a stomach big enough to digest tough plants over long hours. Its size protects it from smaller predators and lets it endure dry seasons with slow patience. The ecosystem does not plan this, yet it shapes it all the same. Where forests and plains spread wide, browsers grow tall and heavy, rising like walking pieces of the landscape. We continue onward until the plain slopes into a marshland. Water laps softly at the edges. Tiny insects hover above the surface. Beneath the quiet water, countless small creatures drift through the currents. A shadow passes beneath us, and a massive shape glides through the murky depth. This is a filter feeder, one of the planet's most persistent ecological roles. A filter feeder is a gentle giant of the water, a creature whose size allows it to gather enormous amounts of tiny food collected in the drifting plankton. It might be a giant fish, it might be a prehistoric armored creature, it might be a whale. The body changes with time, but the role stays the same. Oceans produce billions of tiny organisms. These organisms feed on sunlight or drifting nutrients. They gather in such vast numbers that a large creature can build an entire existence around sifting them from the water. So the giants return again and again. Their mouths widen, their bodies grow long, their movements slow to a graceful rhythm that conserves energy as they swim. The planet does not forget this role. Oceans always offer it, and evolution always fills it. We move on, stepping toward a forest where the shadows stretch long beneath towering trees. Here we find another kind of invitation. A fallen tree lies across the ground, its bark split to reveal soft wood inside. Small insects swarm over it. A group of scavengers moves quietly among the logs and leaf litter. Some are small mammals, others are birds, yet in the past, some scavengers were giants. Enormous birds once strode across plains, feeding on carcasses left by predators. Even earlier, certain dinosaurs filled this same position. They followed herds, relying on their sense of smell to find what had been left behind. Scavengers appear because death appears. Where animals live, some eventually fall. And when they do, a space opens for creatures who can use the leftovers. In rich ecosystems, scavengers grow larger because there is more to find. Their bodies stretch, their strides lengthen, their senses sharpen. Over millions of years, evolution sends new species to take up the same ancient tasks. We walk deeper until the air grows cooler and the ground hardens beneath our feet. A quiet shape moves through the shadows. Its eyes are steady, its steps precise. This is a predator. The role of apex hunter has been reinvented countless times across Earth's story. Sometimes it belongs to enormous fish, sometimes to giant reptiles, sometimes to mammals with long teeth and powerful limbs, sometimes to creatures that do not resemble any living animal. Predators rise whenever herbivores grow numerous. When prey thrives, the world makes room for hunters, and hunters grow large to match the size of their meals. They refine their senses, they strengthen their bodies. They fill a role that ensures balance, one that prevents any single species from overwhelming the plants or the land. This role appears in every ecosystem that becomes rich enough to support it. As we continue walking, moving between plains and forests, rivers and coasts, we see the same truth unfold. Ecosystems carry patterns just as evolution does. When enough food gathers in one place, a browser appears. When tiny life fills the water, a filter feeder rises. When prey thrives, predators follow. When life and death cycle through the land, scavengers move through the remains. These roles invite giants not because giants are inevitable, but because large bodies serve these particular tasks with slow and steady efficiency. The planet creates the conditions. Life fills the shapes. The breeze brushes gently past us. The light softens, and in this moment, it becomes clear that the giants who returned across ages did not simply appear, they were answering. Invitations written quietly into the structure of the world itself. As we step away from the steady rhythm of ecosystems and their quiet invitations, the world around us softens once more. The plains fade, the forests dissolve, the coastlines tilt into a gentle blur. We drift into a space not bound by geography, but by possibility itself. Here, in the quiet folds of time, evolution works like an artist who paints without seeing the full canvas. It adds strokes, erases others, and sometimes, through coincidence alone, lands on the same shapes it created long before. In this calm space, we are no longer watching ancient predators or towering herbivores. We are watching something far smaller and far more mysterious: mutations. Tiny changes in the code of life. Each one is a whisper in the long story of Earth, a shift so small it could fit within the width of a single breath. Yet from these whispers, new species rise, new forms emerge, and sometimes old designs return. We find ourselves standing in a world between worlds, where time flows slowly, gently. Shapes appear like soft outlines, a fin, a limb, a beak, a pattern of bone that seems strangely familiar. We move closer, and the outlines sharpen into forms that resemble creatures from eras long separated. A fish with a shape reminiscent of another that lived hundreds of millions of years earlier. A lizard whose limbs echo those of a far older reptile. A bird whose beak mirrors those of creatures that vanished before mountains rose. None of these creatures share a direct ancestor with the old forms they resemble. Their similarities are accidents, yet they happen often enough that a subtle pattern emerges. Mutations arise randomly. They are like raindrops falling onto a vast surface. Most leave no trace. Some create forms that struggle and fade, but a few land in places where the environment, the physics of bodies, and the needs of survival all whisper yes. In those moments, evolution follows the path that opens before it, even if that path leads to a shape that once existed. Long ago, we watch one of these echoes unfold before us. A small creature scurries across the forest floor. Its limbs stretch in a way that helps it grasp branches. Its tail acts as a counterbalance. It looks like a distant reminder of a species from a much older landscape, but the resemblance is shaped by coincidence. The forest offers branches. The branches favor animals that can grip and climb. Any lineage, given enough time and enough tiny genetic shifts, may happen to stumble into this same solution. These echoes do not belong only to small creatures. Even the giants we have seen owe part of their repeated emergence to accidents in evolution. When the environment allows large bodies to thrive, when oxygen levels and food sources align, random mutations that increase size become useful. They survive, they spread, they accumulate. Slowly, over countless generations, these scattered mutations build a giant, not because the world remembers an older one, but because the same roll of the evolutionary dice produced a similar result. In this space, we begin to see that many of evolution's echoes are built not from intention, but from probability. Over millions of years, with millions of organisms each carrying millions of chances for mutation, some outcomes begin to repeat. It is like walking through a long field of tall grass. If many travelers cross the same field, some will naturally follow similar steps, not because they saw the paths of those before them, but because the terrain quietly guides their feet to similar places. Evolution often follows these faint paths of least resistance. Sometimes, different species evolve similar teeth because they all feed on similar prey. Sometimes, wings emerge in separate lineages because the shape of the air offers only a few workable designs. Sometimes, fish-like forms appear again and again because swimming through water encourages streamlined bodies. At other times, the echoes are subtler: a curve of bone, a shape of jaw, a pattern of spots. If we look at the history of life from far above, these echoes seem almost inevitable. Millions upon millions of genetic possibilities scatter endlessly, yet the world accepts only those that help a creature survive. When certain forms offer solutions that work, even by chance, evolution stumbles toward them. Maybe not immediately, maybe not in a straight line, but eventually, we drift further through this quiet space, watching these patterns unfold. Forms appear, vanish, and reappear in gentle cycles. None are identical. Each carries the mark of its own lineage. Yet, the echoes are unmistakable. Nature does not repeat itself perfectly. It simply finds shapes that work, shapes that solve problems efficiently, shapes that survive the filtering of time. Sometimes, these shapes arise by direct pressure from the environment. Other times, they emerge from the accidental meeting of random mutations and opportunity. But beneath it all lies a gentle statistical truth. In a world where life experiments endlessly, where billions of organisms are born in every age, where time stretches in deep, patient cycles, certain outcomes become likely, even when no intention guides them. We pause, letting this realization settle. In the soft silence of evolutionary possibility, we see that many of the giants and familiar forms across Earth's story did not return because the world remembered them, nor because evolution aimed to recreate them. They returned because chance aligned with opportunity, and because across the vastness of time, even randomness has its patterns. The echoes fade, the space around us grows still, and we continue forward, carried by the quiet knowledge that life repeats itself not only through purpose, but through accident, woven gently into the fabric of deep time. The quiet echoes of accidental repetition drift softly behind us as we step forward into another gentle chapter of Earth's story. Here, the world feels more grounded. Shapes come into focus, movements carry purpose. The air seems to hold the soft hum of inevitability, as if nature itself is guiding certain forms toward the same solutions over and over again. This is where evolution stops stumbling in the dark and begins following the faint outline of what works best. The landscape before us stretches wide and calm. Rolling plains rise into low hills. Rivers move with slow confidence across their beds. Forests sway like vast green seas. And in this broad world, we begin to see something familiar. Bodies shaped not by coincidence, but by usefulness. Designs that return not because of chance, but because they solve problems with quiet perfection. In the distance, we watch a large herbivore move slowly across the grass. Its legs are straight and sturdy, holding its weight with gentle strength. Its neck arches with balanced grace as it grazes on leaves from tall branches. This shape is not new. We have seen echoes of it before in creatures separated by millions of years. Long necks for reaching, column-like legs for support. A large body that moves steadily rather than swiftly. It is a form shaped by necessity and refined by time. Every part of it whispers efficiency. Evolution repeats giants like this not because it remembers the past, but because the present keeps asking the same questions. How does a creature reach high vegetation without climbing? How does it move long distances without tiring? How does it withstand seasons of scarcity with quiet resilience? The answers, shaped over countless generations, lead again and again to similar solutions. A large body, long limbs, slow, steady digestion, a design that works well enough to rise in many eras, carried by different families of animals. We walk further, the air warming gently around us. In a nearby river, something stirs. A large creature breaks the surface, water cascading down its broad back. Its body tapers smoothly at both ends, shaped like an elongated teardrop. This form appears in ichthyosaurs. It appears in dolphins. It appears in ancient fish and modern whales. It is an answer sculpted quietly by the water itself. Water rewards shapes that slip through it with minimal effort. A strong core, narrow fins, a powerful tail. No matter which lineage enters the ocean, those that adopt this shape move with ease, conserve energy, and survive long enough to thrive. This is optimal form in motion. Evolution does not need to force it. Physics suggests it so strongly that different species discover it separately, guided by natural selection toward the same ideal. Even predators follow this path. On land, in air, and in water, the same patterns reappear. A predator needs speed, strength, and precision. It must see clearly, grip firmly, and move decisively. When these needs arise across different ages, natural selection encourages similar solutions. Sharp teeth, forward facing eyes, muscular limbs, streamlined bodies. The predators themselves may look different in detail, but the underlying design repeats, not from memory, but from efficiency. We turn toward the forest, where sunlight filters through the leaves in soft, golden patterns. A creature with a curved beak hops from branch to branch, gathering seeds. In its motions, we see another quiet truth. Certain tasks demand certain shapes. A seed eater needs a beak strong enough to crack shells. A climber needs flexible limbs and gripping feet. A fast runner needs long legs that move like pendulums. These designs emerge repeatedly because they make life easier in these roles. Even small adjustments in form, given enough time, guide evolution toward the same peaks of performance. A lineage may vary, experimenting with new traits, but those traits that help a creature survive longer and reproduce more tend to remain, those that do not fade into the background. Over time, natural selection sculpts bodies toward what works well, toward what solves problems smoothly, toward what fits the environment like a stone fits a riverbed. This is the silent pressure behind repeated giants, not a deliberate force, but a steady push toward optimal form. The world does not ask for perfection, it asks for balance. Those forms that meet the balance most gracefully rise again and again. We walk now along the edge of a calm lake. The water reflects the sky like a sheet of glass. In the shallows, long shadows glide beneath the surface, fish shaped in ways that echo forms millions of years apart. Insects above the water carry wings that fold and unfold with delicate precision. Even the plants that grow along the shore bend in patterns that maximize sunlight and minimize damage. Everywhere we look, nature invites efficient design, and evolution answers through repetition. This repetition is not a sign of limitation. It is a sign of refinement. Life explores many paths. Many fail. The ones that succeed become quiet templates, shapes that reappear whenever conditions align. When food is abundant, bodies grow. When prey runs fast, predators become streamlined. When forests rise, browsers stretch their necks. When oceans bloom with plankton, filter feeders widen their mouths. These patterns are not habits. They are the gentle mathematics of survival. As we stand on the lake shore, the breeze moves softly through the grass. The world feels calm and complete. In this stillness, it becomes clear. Evolution is creative, but it is also practical. It does not aim for novelty. It aims for stability. And whenever the planet offers the same opportunities, evolution returns to the same elegant solutions, allowing giants and familiar forms to rise from entirely new beginnings, guided by the quiet logic of what simply works best. The calm shoreline where optimal forms drifted into view begins to fade, and the world around us shifts once more. The air becomes heavy with a quiet stillness, almost as if the earth is holding its breath. We step into a moment that repeats itself throughout deep time, a moment when life pauses and the future hangs suspended. This is the edge of an extinction. Not the violent blast itself, not the rushing fire or the choking ash or the sudden cold that follows. Those scenes belong to the chaos we have already stepped past in earlier parts of the story. Here, we arrive just after the storm, when the sky has begun to clear and the silence is deep enough to feel. All around us, the landscape seems emptied. Plants remain, but they stand quietly. Rivers still flow, but the water moves without disturbance. The air carries no calls from towering herbivores and no echoes of great predators. The world is thinned, lightened, humbled, And in this open space, something ancient and repeating begins. Small animals emerge first. At our feet, tiny shapes scurry between rocks and low-growing plants. Shy mammals the size of mice, insects that survived within sheltered crevices, small reptiles that hid in underground burrows. In the ocean, little fish dart through still waters. In the forests, small birds hop between branches. Life has not disappeared. It has simply retreated into forms that endure hardship well. Small bodies are nimble in disaster. They need less food. They find shelter in tight corners. They breed quickly, helping their populations rebound long before the world heals. These small survivors fill the silence left behind by vanished giants, gradually reshaping the land in subtle ways. They eat seeds, they spread roots, they clear dead vegetation, they become the quiet caretakers of a wounded earth. As seasons pass into centuries, the world begins to stitch itself back together. Plants spread across empty plains, forests take root once more, oceans slowly bloom with new life, rivers carve fresh paths, and the small creatures, thriving in this recovering world, spread into the open niches. For a time, the earth feels like a place built for delicate steps and careful movements. But as stability returns, something begins to change. We watch as the landscape around us grows richer. The trees grow taller, the plains stretch wider, the oceans gather dense clouds of plankton beneath the waves. Life begins to multiply and diversify. Soft green light filters through a rising canopy. Herds of early herbivores appear, small at first, moving lightly through meadows and thickets. Predators follow them, cautious and lean. This is the dawn of ecological turnover, the moment when the emptiness left by extinction becomes a series of invitations. The world regains enough energy, enough food, enough calm to allow new forms to flourish. Small animals, once dominant due to necessity, begin encountering opportunities to grow. In the distance, we see one of these creatures. A small herbivore, feeding in a patch of fresh plants, begins to pass its traits forward. Generation by generation, its descendants shift. They become slightly larger, then larger still. A longer leg helps them move more efficiently. A stronger jaw allows them to process tougher vegetation. Each change gives a small advantage. Across millions of years, these tiny increments accumulate until the animal before us is no longer small. It is becoming a giant. The world's stability makes this possible. Abundant food supports growth. Predictable seasons allow species to plan their lives around calm cycles of birth and migration. Expanding ecosystems create space large enough for heavy bodies to roam. Predators become stronger, pushing herbivores to grow for defense. Herbivores become more numerous, encouraging predators to grow in return. A new balance forms, shaped by size and strength. If we turn our gaze to the ocean, the same pattern plays out. After an extinction thins the waters, small fish and resilient invertebrates dominate. They rebuild the food web layer by layer. Over time, as nutrients return and currents grow rich again, larger predators emerge. Streamlined bodies appear in the distance. Powerful tails carve through the water. Far below, filter feeders begin to swell in size, feeding on blooms of plankton that flourish in a stable sea. Giants rise only when the world is ready for them. This is the pattern etched into every major extinction event. Chaos removes the old giants. The world resets. Small survivors step out of the shadows. Then, slowly, as the earth finds its rhythm again, evolution begins weaving new giants into the empty spaces. These giants are not recreations of what came before. They are fresh answers to familiar opportunities. We pause in a quiet meadow where the first signs of a new age shimmer in the warm light. Young forests stretch upward, early rivers sparkle. The air hums with insects and the songs of small birds. Yet, beneath this gentle scene lies a potential waiting patiently for its moment. All the ingredients for giants are here: food, space, stability, time, and soon enough, evolution will shape them again. The breeze carries a soft murmur through the grass, and we stand in the stillness, knowing that giants are not born in the chaos of destruction. They are born in the calm that follows. They rise slowly from the quiet work of small creatures, from the healing of the land, from the balance restored after loss. In this peaceful space, we continue onward, following the slow unfolding of Earth's story as it prepares once more to imagine life on a grand scale. As the calm meadow settles behind us, the world around begins to shift once again, not through sudden motion or dramatic change, but through something far softer. The air takes on a different texture, the light deepens, the land beneath our feet exhales a long and ancient breath. We are stepping into the quiet machinery that moves beneath all life on Earth, the chemical rhythms that rise and fall like tides across millions of years. Here, in this slow and steady space, we begin to see another layer of the pattern that shapes giants. It is not a creature or an environment, but the planet itself, gently altering its own chemistry over vast stretches of time. The ground beneath us shimmers faintly, and we drift into an era long before humans, long before the giants we have met. The air is thick with warmth, volcanic fields glow on the horizon, rain falls heavy and rich with minerals. In this ancient world, carbon dioxide is high, carried through the sky like an invisible blanket. Plants grow quickly, drawing energy from sunlight with a hungry intensity. The oceans carry nutrients washed from young mountains, feeding single-celled organisms that bloom in immense numbers. Carbon dioxide has always cycled through Earth's story, rising and falling like a quiet heartbeat. When volcanic activity grows or continents shift, the air can thicken with carbon dioxide. When mountains rise and weather breaks them down, carbon dioxide is drawn back into the land or locked inside stones. These long, slow cycles shape climate, plant life, and the oceans more profoundly than any single event. As we stand within this warm, high carbon dioxide world, the oceans expand with life. Plankton, tiny and delicate, drift in thick shimmering clouds. Their bodies gather carbon. Their remains sink to the seafloor, building deep layers of trapped minerals. The chemistry of the ocean shifts with every bloom and every fall. The water becomes rich with nutrients, carrying traces of life from surface to depth. This richness is where giants begin. We drift into the water, letting ourselves follow the quiet movement of currents. The ocean feels full. Sunlight penetrates in golden beams, illuminating countless drifting organisms. In this openness, early filter feeders gather, moving slowly through the bloom. They open wide mouths to draw in water, straining out the tiny lives that fill the sea. These creatures are not yet giants, but their size hints at what the future holds. Ocean chemistry decides the limits of those futures. When nutrients rise, plankton grow. When plankton grow, filter feeders have more food. And when food becomes abundant, evolution begins its long process of shaping larger and larger bodies. The ocean rewards size. A bigger filter feeder can sweep more water with each slow stroke. It can travel far across nutrient-rich seas without tiring. It can survive leaner seasons by storing more energy. As we drift deeper, time shifts around us. The warm, high, carbon dioxide world fades. Mountains rise. Rainfall changes. Nutrients shift. The ocean chemistry adjusts once more. Some eras grow poorer in nutrients. Others grow richer. With each change, the size of ocean creatures adjusts. In leaner times, filter feeders shrink or vanish. In generous times, they grow again. We watch one of these generous times unfold. The oceans lighten with high oxygen. Winds carry dust rich with iron into the water, feeding plankton blooms that spread like soft green clouds. This is a world where giant filter feeders thrive. Their bodies stretch long, their mouths widen into gentle scoops. Their slow movements sweep through fields of drifting life, gathering nourishment with calm efficiency. It is this chemistry, not chance alone, that determines when giants return to the sea. Oceans with high nutrients and stable temperatures can support creatures far larger than today's whales. In earlier eras, these giants took many forms, from bony fish to long-bodied invertebrates. They evolved independently, guided by the same opportunity that appeared again and again. Rich oceans, abundant plankton, space to grow. We rise from the water and drift into a cooler era. Carbon dioxide lowers. Ice spreads across the poles. Nutrients shift once more, carried by cold currents that stir the oceans more deeply. Plankton become abundant again in a different pattern, and filter feeders respond. New lineages follow the old path, reaching large sizes when food allows, shrinking when the world becomes sparse. Every rise and fall of carbon dioxide, every shift in ocean nutrients, every bloom and every quieting, all of these shape what life can become at any given moment. We walk along the shore now, feeling the gentle pulse of these cycles beneath our feet. The chemistry is invisible, yet its influence is everywhere, in the forests, in the grasslands, in the oceans that cradle the memory of ancient bloom after ancient bloom. The giants that fed from these waters were not simply accidents of evolution. They were reflections of Earth's changing chemistry, answers to the question of how best to live in oceans full of drifting life. As we step away from the shoreline, the world settles again, holding the knowledge of countless cycles within its stillness. The chemistry of the planet has shaped the size of life before, and it will shape it again whenever the oceans whisper that the time for giants has returned. As we leave the shoreline where Earth's chemistry whispered its quiet influence, the world around us shifts once more. The air becomes softer, more patient, as though time itself has slowed its breathing. We step into a new chapter of the planet's story, one shaped not by the land or the ocean or even the climate alone, but by the rhythm of life itself. Here, in this gentle space, we explore how creatures choose to grow, to age, and to bring new generations into the world. These choices, woven through countless eras, have guided evolution toward giants again and again. The landscape around us settles into a broad savanna. Warm light glows through tall grasses. In the distance, large animals move with careful steps. Their motions are slow and deliberate, as if they are in no rush to reach the horizon. These are long-lived creatures. Their lives unfold in extended arcs. Their growth is steady. Their offspring are few, and in their bodies we begin to see the quiet rule that links time with size. Reproductive strategy, the way an animal balances survival with reproduction, shapes its entire existence. Some creatures live quickly and briefly. They grow fast, breed early, and produce many offspring. Others live slow and long. They invest deeply in each child. They wait for the right conditions to bear young. They survive for decades. This difference between fast life histories and slow life histories is one of the hidden engines behind gigantism. We move closer to one of these gentle giants grazing at the edge of a grove. Its eyes are calm, its breath deep, its steps unhurried. This creature is built for endurance rather than haste. Its long lifespan gives it time to grow large. Year after year, its bones thicken, its muscles develop, its body expands in a way that no short lived creature could ever match. The connection feels simple once we see it. Time allows size. Creatures with slow life histories are often those that rise into giants. Their bodies grow over long seasons. Their skeletons strengthen over many years. They can weather droughts, migrate across long distances, and survive harsh cycles that would overwhelm a fast living animal. For them, growing large is not merely an option, it becomes a pathway to resilience. Yet long life alone is not enough. Something else is required. The world must give them the space and calm to grow. We walk now into a forest whose branches sway gently in the upper canopy. The air feels steady. Seasons cycle softly, without violent swings. Rain falls when expected. Food appears in reliable patterns. This is a stable climate, and stability is one of the most powerful forces behind repeated giant lineages. When the climate settles into long stretches of calm, ecosystems become predictable, plants bloom in regular cycles, forests expand and recover, ocean currents stabilize. In these conditions, slow growing creatures can invest in large bodies without fear that sudden changes will wipe them out. They can commit their energy to long lives, few offspring, and steady growth. A world like this favors giants. We glance upward as a large bird glides above the treetops. Its wings spread wide, catching soft currents that lift its heavy body with ease. This bird belongs to a lineage shaped by stability. It lays few eggs, it raises each chick with careful attention. Over many generations, its body has grown larger because its long lifespan supports such growth. It soars not only because the air allows it, but because time allows it. Even in the oceans, we see the same pattern. Filter-feeding giants, apex predators, and long-bodied swimmers often come from species that live many years. Their slow reproductive strategies allow them to reach great sizes. They do not rush through life. They grow during periods when the seas are rich and predictable. When those conditions last long enough, new giants begin to appear. We drift deeper into this calm world and find smaller creatures moving among the underbrush. These animals live quickly. They have many young. Their lives begin and end within short stretches of time. Their bodies remain small because small size lets them follow their strategy more effectively. Quick lives and large bodies rarely exist together. The energy demands are too high. The risks are too great. This gentle distinction, repeated across millions of years, helps explain why giants reappear in eras of stability but seldom in eras of chaos. After extinction events, the world becomes unpredictable. Fast-living species dominate. They breed quickly, adapt rapidly, and fill empty landscapes. Giants cannot rise in such turmoil. Their growth requires patience, safety, and time. As we walk along a narrow path that winds through the tall grasses of another age, the wind carries a sense of quiet endurance. We begin to understand that gigantism is not simply about strength or opportunity, it is also about the rhythm of life. Long-lived creatures build their futures, slowly, weaving their survival across generations with careful threads. When the climate stabilizes, these threads grow strong. Over thousands and thousands of seasons, they form lineages whose bodies stretch toward impressive sizes. Their shapes mirror earlier giants because the rules guiding them have not changed. Stable worlds encourage longevity. Longevity encourages growth, and growth, given time, creates giants. We pause at the crest of a low hill, watching the landscape settle into soft evening light. Across valleys and oceans, through forests and plains, the same quiet truth rises again and again. The path to gigantism is not rushed, it is patient, slow, and steady. It waits for the world to calm, it waits for life to breathe, and then, gently, it begins to grow. The gentle world, shaped by long lives and slow rhythms, begins to dim at the edges, as though a soft dusk has settled over it. The air cools, the grasses sway with a quieter motion, and once again, we find ourselves drifting into a pattern that has echoed through every age. The rise of giants is only half of the story. Their disappearance and their eventual return completes the cycle. We stand in a landscape that feels older than the one before. The giants that once walked here have faded from sight. Their footprints are filled with dust. Their shadows no longer stretch across the plains. The silence they leave behind feels wide and heavy, as if the world has exhaled and has not yet drawn another breath. This is the moment when giants vanish. Large creatures carry an elegance shaped by time, but that elegance comes with a delicate truth. Giants depend on stable seasons. They rely on plentiful food. Their bodies require constant nourishment, careful temperatures, and ecosystems rich enough to support them. Their lives are balanced on long threads, and when the world shifts quickly, those threads break. We walk through a forest where the sunlight falls in thin beams. The trees stand still, almost watchful. Beneath them, only small animals move through the underbrush. The giants that once fed on these leaves and branches are gone. Their absence tells a clear story. They could not change fast enough. Large species live slowly. They reproduce slowly. Their young take time to grow. They cannot adapt in a single season or even a few hundred seasons. When climate swings abruptly, or food disappears, or new predators emerge, smaller creatures adjust in quick bursts of evolution. Large animals cannot. Their size becomes a weight that the new world will not carry. As we move onward, the forest opens into a wide clearing where the wind carries the faint warmth of another age. The ground is scattered with the remnants of plants that once fed enormous herbivores. Without those herbivores, the plants grow differently. Some spread too thickly, others fade. The balance changes, and with it, the web of life above and below the soil. Giants depend on food chains that are equally large. A towering herbivore needs vast amounts of vegetation. A giant predator needs abundant prey. When these food webs contract after droughts, temperature shifts, volcanic winters, or oceanic changes, giants are the first to fall. Smaller creatures survive because they need less and can shift their diets. Giants cannot. We step closer to the edge of a dried riverbed. The cracked earth glimmers under soft light. Here, an ancient floodplain once supported great migrating animals. Their movement kept the land open. Their feeding shaped the vegetation. Their presence influenced entire ecosystems. When they disappeared, the land changed. Some areas grew thick with plants too tough for smaller animals. Other areas dried because the vegetation patterns shifted. The land itself seemed to sigh under the loss. This repeated collapse appears almost everywhere across deep time. In the oceans, giant filter feeders vanish during nutrient crashes. Massive predators disappear during cold spells or when prey declines. Thick-shelled invertebrates vanish when ocean chemistry shifts. On land, long-necked browsers vanish during droughts or when forests transform. In the sky, giant flying creatures vanish when air density changes or when their food sources dwindle. The fragility of giants is not a flaw, it is simply the price of their scale. But time moves forward, and the planet does not stay in its wounded state forever. We step now into a landscape slowly healing. The trees are young. The air carries moisture again. Small animals scurry across the soft ground. They are fast and adaptable, shaping new patterns across the land. This is the early stage of ecological recovery, the same quiet beginning we once walked through after extinctions. Small creatures restore the world in slow layers. Their feeding redistributes nutrients. Their burrowing loosens the soil. Their migrations gather seeds. They open the way for richer ecosystems. And with each passing generation, the land grows steadier. The oceans follow the same rhythm. Tiny plankton bloom, small fish return, coral rebuilds. As nutrients flow, the food chain deepens. Stability begins to settle like a gentle blanket across the world. And then, quietly, the stage is set again. In the distance, we see the form of a creature slightly larger than the others. It moves with a slow confidence. Its diet grows. Its descendants grow. Year after year, century after century, its lineage expands into shapes that echo the giants of ages past. The world now offers food and space and calm. Evolution responds. What once disappeared begins to return. The cycle is not rushed. The world waits until it is ready, and only then do giants rise again. We follow this unfolding pattern as the horizon glows with soft evening light. Across eras, the same truth repeats. Giants disappear because the world becomes too fragile to hold them. They return because the world heals. They are shaped by abundance, undone by instability, and reborn through slow renewal. The land settles into quiet, the breeze brushing over the ground where new giants will one day stand. In this gentle glow, we see that extinction is not the end of the story. It is a pause, and when the pause lifts, the world breathes out again, ready to imagine life on a grand scale once more. The quiet landscape before us settles into a gentle twilight, as if the world itself is pausing to look forward. We have walked through ancient oceans, drifting forests, quiet savannas, and the shadowed valleys where giants rose and fell. Now, we arrive at a place where time stretches ahead instead of behind. The air feels almost weightless here. The horizon seems wider, and the question before us opens like a soft doorway. Could the earth make giants again? We stand on a warm plain that resembles the present day, though the colors feel softened, like a memory or a dream. Grass ripples in a calm wind. Small animals dart through the brush. Birds call to one another above tall trees. The world feels alive, yet something is missing. Something needed to lift life back into forms the size of ancient titans. We move slowly across the open field, noticing how few animals reach enormous sizes today. Even the largest creatures, such as whales or elephants, are remnants of older ages rather than new beginnings. Their lineages stretch back to eras when the world was richer, wilder, and more forgiving. It becomes clear that the first condition needed for giants is abundance, and our modern Earth, beautiful as it is, does not yet offer the abundant resources required. The oceans, though vast and bright, do not brim with the same immense plankton blooms that once fed giant filter feeders. Pollution and shifting temperatures strain the delicate chains of life. The land, though green, is fragmented. Forests are scattered. Grasslands shrink under pressure. Giants depend on plentiful food spread across wide, connected spaces. Today, these spaces exist only in small remnants. As we continue forward, a gentle warmth settles across the scene, and the light deepens into something that feels almost hopeful. Ecosystems can recover. They have done so before, again and again, after extinctions far greater than anything humans have caused. If given enough time, landscapes rebuild themselves. Forests weave back together. Oceans stabilize. Coral returns. Rivers resume their ancient work of carrying nutrients from land to sea. In this imagined future, long after human impacts have softened, The Earth may regain the quiet rhythms needed for giants to emerge. The recovery is slow. It takes thousands of years, then tens of thousands, then millions. But across deep time, patience is one of the planet's most reliable qualities. We drift into such a possible future. The land is green in broad strokes. Forests stretch across continents like deep breathing lungs. Grasslands sweep in great arcs between mountains. The oceans move in strong, balanced currents rich with life. Plankton bloom in thick clouds beneath the surface. The world feels ready again. It holds the ingredients that once shaped giants. If giants were to rise in this future, who would become them? We step quietly through a forest where small mammals scurry among looping roots. Some of them already show signs of slow, steady growth. Their lives lengthen across generations. They take longer to mature. They expand their diets. These are early steps toward gigantism. Given enough time and stable conditions, one lineage could grow larger, gaining size to defend against predators or reach higher vegetation. We wander to a coastline in this future Earth. The water glimmers beneath the afternoon sun. Beneath the surface, long-bodied fish glide through nutrient-rich currents. Some feed on drifting plankton. Others sweep their wide mouths through clouds of small organisms. Their bodies, though still modest, carry the streamlined shape that often precedes ocean giants. If the oceans remain rich, these creatures could grow larger with each passing age. Above us, birds drift through the air in slow circles. Most are familiar in size, but here and there we notice one with longer wings, broader chests, and more powerful strokes. If air currents strengthen in a warming world, if coastal winds become steady and predictable, perhaps a new lineage of large flyers could emerge. Not the towering pterosaurs of distant epochs, but something shaped by its own era, following the same gentle rules of efficiency and lift. Farther inland, we find reptiles sunning themselves on warm rocks. Most remain small, but one lineage stands out. These reptiles live longer than others, tolerate heat well, and feed on vegetation in steady patterns. Under stable climates, slow-living reptiles can grow large. It has happened before. It could happen again. Yet even in this imagined future, we see that giants do not appear quickly. They do not burst into existence. They rise gradually, as ecosystems deepen and food webs stretch upward layer by layer. The process is patient, quiet, organic. It takes a world that breathes in long, calm rhythms. We walk a little farther, and the land around us begins to settle into a tranquil glow. The future is not fixed. It is shaped by countless choices and countless natural changes. But the rules that shape the giants of the past remain written into the planet, waiting for a world ready to support such grandeur again. The conditions are simple, though not easy. The earth must be abundant, it must be stable, it must offer time without disruption, and it must weave food webs rich enough to carry large bodies through season after season. If these threads come together, then yes, giants could return. Not the ones we knew, not replicas of ancient titans, but new forms shaped by future forests, future seas, and future winds. Life would carve them gently, patiently, from the quiet possibilities that open whenever the world finds balance. We step away from the imagined future as the light softens around us. The path ahead remains open. Giants may return one day, not because history insists upon it, but because the rules of life, space, and time still hold the door open for them, waiting for the right moment when the earth whispers that the world is ready once more. The future earth fades gently from view, and we find ourselves drifting once more through a quiet, timeless space. The air feels still here, as though the world has paused between breaths. It is a place where the patterns we have followed through oceans, forests, skies, and deep time finally begin to gather into a single soft understanding. We have watched giants rise and fall. We have seen their forms repeat across eras that never touched. And now, in this calm moment, the deeper meaning behind these echoes begins to unfold. We stand on a gentle hillside that overlooks the memory of countless worlds. Below us, rivers carve their way through ancient valleys. Plains shimmer under afternoon light. Distant mountain ridges stretch into soft silhouettes. Every part of the landscape carries its own quiet truth about how life changes and adapts. Evolution is often described as random, and in many ways it is. Mutations arise without intention. New species appear not because the planet asks for them, but because tiny changes in DNA accumulate over generations. Yet as we look across the long story of life, the randomness begins to feel guided by something quieter and more subtle. Not purpose, not design, but limits, rules, patterns shaped by the shape of the world itself. We close our eyes for a moment and let the memory of the ancient oceans return. In those waters, the same sleek predators rose more than once. Streamlined bodies, powerful tails, eyes set forward for hunting. These shapes were not accidents. They were solutions shaped by water. Water offers resistance. It rewards smoothness. It encourages certain body plans and discourages others. Evolution, even in its randomness, leans toward what works, and what works is often what has worked before. We open our eyes again and walk slowly into a forest whose canopy moves with soft green breaths. Here, long-necked creatures reach toward leaves that grow high above the forest floor. Not one lineage, but many, again and again. The trees did not create these creatures, but they offered an invitation that many different ancestors answered in similar ways. A long neck, a sturdy body, a slow, steady digestion. These solutions emerged separately because the problem they solved remained the same: physics, chemistry, geography, climate. These are the quiet forces that guide evolution's possibilities. They shape the spaces where life can grow, the boundaries of what bodies can do. They do not dictate the exact form of each creature, but they narrow the options. They tilt the scale, turning some paths into well-worn trails and others into dead ends. Over millions of years, these trails become visible as patterns. We move to the edge of a calm sea, where waves break in slow, rhythmic lines. The water carries the memory of plankton blooms, oxygen surges, and shifting currents. Chemistry shapes what life the ocean can sustain. When nutrients rise, giants follow. When they fall, giants disappear. These patterns are not random. They are the natural response of life to chemical rhythms written into the sea. Even extinction, in its violence, reveals another layer of order. When the world resets, small creatures take over. As stability returns, giants reappear. Not the same giants, but giants nonetheless. Evolution responds to empty spaces and available energy. It fills roles that ecosystems demand. It rebuilds the towering browsers, the immense filter feeders, the powerful predators. Different species, different lineages, the same answers. We walk through a quiet valley where the rocks beneath our feet hold fossils from different ages. Here, the evidence feels almost gentle. Each fossil is an echo, a reminder that life has returned to similar shapes again and again, not because it remembers, but because the world encourages certain solutions. In this valley, the patterns reveal a hidden order. Evolution is not directed, yet it follows the contours of the world. It does not plan, yet it converges on similar forms when facing similar challenges. It does not repeat itself exactly, yet its echoes can be heard through deep time. When we look at all of these patterns together, something soft and profound emerges. The repeated rise of giants is not a coincidence. It is a quiet reflection of how life interacts with physics and chemistry and climate. It is the earth answering its own rhythms through the bodies of living beings. It is a conversation between chance and law, between possibility and limitation. We stand at the edge of the valley. As the breeze moves through the grasses, the world feels vast and patient. The patterns we have followed do not make evolution predictable. They simply show that randomness is shaped by context, that the world sets boundaries on what life can become. And within those boundaries, the same elegant solutions appear again and again. The giants that walked the earth more than once were not accidents. They were signs of an underlying harmony, a hidden order, woven through oceans and forests and skies, an order that reveals how deeply life is shaped by the planet it inhabits. In this quiet understanding, the landscape rests, and we continue gently onward, following the soft rhythm of a story written across millions of years. The gentle valley of hidden order fades into a wash of soft color, as though time itself has loosened its grip and allowed the world to drift into something quieter. The air becomes warm in a timeless way. The horizon stretches in a peaceful arc, and we find ourselves no longer walking through a single age or landscape, but moving slowly across the entire sweep of Earth's history, as if we are floating above a tapestry woven from countless lives. This is the space of reflection, where all the echoes we have seen begin to settle into a calm and steady rhythm. The land below us shifts with the softness of a dream. Oceans rise and recede. Forests bloom and fade. Mountain ranges rise like slow breaths and crumble again. Each transformation flows seamlessly into the next, and through it all, the shapes of life move in patterns we now recognize. Some appear for a moment and vanish forever. Others return again and again, like melodies the earth hums when conditions invite them back. We watch the early oceans brighten with the faint light of distant suns. Simple forms drift through the water, growing braver and more complex as time stretches onward. When the moment is right, long-bodied hunters rise from those waters, their shapes uncannily similar despite belonging to different ages. The water does not remember them, yet it guides new species into familiar outlines because the rules that shape movement have not changed since the beginning. We drift over ancient coastlines where forests press close to the shore. In one era, necks stretch toward the leaves. In another, entirely unrelated creatures reach upward in the same graceful arc. The trees ask the same question: who will climb into the sky to feed? And evolution answers with whatever lineage stands closest to opportunity. The shapes echo across ages, not because life copies itself, but because similar challenges draw out similar solutions. As we float higher, the pattern becomes clearer. The earth is not a blank canvas. It is a landscape filled with gentle constraints. Gravity pulls, water resists, air lifts, soil feeds, sunlight warms. Within these conditions, life experiments endlessly, yet those experiments tend to land near the same few solutions whenever the world offers the same invitations. The echoes repeat softly across eons, like footsteps along a well-worn path. The giants we have followed, those immense creatures who appeared in so many different ages, feel like reflections of the world's own moods. When the planet becomes generous, giants rise. When it tightens, they fade. When it heals, they return, shaped anew but carrying the same quiet dignity as their predecessors. Their bodies are reminders of what the earth becomes when it stretches into abundance. We lower ourselves toward a sunlit meadow that seems to exist outside any particular time. The grasses ripple gently, birds circle lazily in the sky above. In the distance, shadows hint at large creatures moving thoughtfully across the plain. They are not from any real age. They are simply the idea of giants, carrying the echoes of all that came before. Their shapes are familiar yet dreamlike, as if formed from the memory of deep time rather than a single lineage. Here, the world feels suspended between past and future, and in this suspension, we can sense how evolution's patterns are less like rules and more like resonances. Life responds to the planet the way music responds to an instrument. The same strings, when plucked in the same way, produce the same notes. The same environments, when offered to different lineages, produce the same shapes. Not identical, but similar. Not copies, but harmonies. We walk slowly through the meadow, noticing each subtle echo, a curve of bone that resembles a creature from a far older age, a stride familiar from a lineage long gone, a pattern of feeding or moving or swimming that has appeared in many forms before. These glimpses feel like reminders that life is not simply random chaos nor strict order, but a gentle blend of the two. Life asks countless questions. How do we move? How do we eat? How do we protect ourselves? How do we reach the sunlight, find the food, escape the danger? And across ages, evolution explores the possibilities again and again. Sometimes the answers are new. Sometimes they are echoes of something ancient. But the beauty lies in the repetition, in seeing how the same question can be asked by entirely different worlds and answered with shapes that feel familiar yet fresh. We pause at the edge of a small lake, its surface perfectly still. Reflections ripple softly, as if carrying the memory of all the forms we have witnessed. In the water, we see hints of ancient cephalopods, streamlined swimmers, long-necked browsers, armored titans, delicate flyers, not in detail, but in motion and suggestion. Their outlines overlap and blend until they become a single calm story told across the ages by the earth itself. The sun lowers in the sky, casting warm light across the land. Everything feels connected. The oceans, the forests, the creatures large and small, the patterns that rise, fade, and return. The echoes hum in the stillness, revealing that life's answers may shift in form, but not in spirit. The deep rhythm of evolution continues, steady and patient. As the light softens into a gentle glow, the entire world seems wrapped in a calm understanding. Life has always tried similar answers to different questions, not out of repetition alone, but out of harmony with the planet that shapes it. The echoes are part of the Earth's quiet poetry, patterns written not in words, but in wings, bones, shells, and silhouettes. We linger in this stillness, letting the beauty of these repeated forms settle around us like a soft blanket, knowing that each echo is a quiet reminder of life's unending creativity, shaped by the slow, steady hand of deep time. The landscape around us softens, as if the world itself is slowly exhaling. Colors settle into gentle hues. The air grows warmer and still, like the closing moments of a long and thoughtful day. After journeying through so many ages, shapes, and echoes, we find ourselves in a quiet place where the vast story of Earth can rest for a while, and we can rest with it. All around us, the patterns we have followed begin to drift into memory. The giants of the deep sink again into their ancient waters. The long-necked browsers fade back into forests that no longer exist. The armored titans return to their distant horizons. Even the silent shapes of the sky, the ones who once glided with wings that brushed the wind, slip gently into the tapestry of deep time, their presence felt more than seen. In this hush, the Earth's patience becomes clear. It is a patience measured not in years, but in millions of years. It is the quiet endurance of a planet that has seen oceans rise and fall, climates warm and cool, continents wander across the globe like drifting islands. Through all of this, life has taken its time, learning, losing, rebuilding, and occasionally stumbling upon the same solutions again and again. Those echoes we traced, the repeated giants and familiar shapes, feel less like coincidences now and more like reflections of a world that guides life softly through its possibilities. Evolution is not hurried, it is not careless. It is the slow unfurling of countless small changes, shaped by gravity, water, air, sun, and the tender limits of what bodies can do. And across deep time, these forces create a rhythm so steady that it feels almost like a heartbeat. A shape that works often returns. A strategy that thrives will bloom again when the world is ready. Life does not cling to the past, but it remembers in the only way it can, through patterns that reappear when the same conditions call them back. These echoes show us that the earth itself holds a kind of quiet wisdom, one that unfolds slowly in the background of every age. As we sit with this understanding, the world around us becomes even calmer. The breeze softens, the light fades into a gentle glow, like the last warm colors of evening sliding across a peaceful sky. The long journey we have taken, from the earliest oceans to the questions of far future worlds, settles into a single feeling of stillness. The resilience written into life's story becomes almost tangible here. Life has collapsed many times, and it has always returned. Giants have fallen, only for new ones to rise from completely different families. Shapes that once seemed lost forever have appeared again in new forms, shaped by nothing more than the old, unchanging laws of physics and opportunity. These echoes, these repetitions, speak quietly of endurance, of persistence, of the strength that lies in simply continuing even after great loss. And in that soft message, there is something deeply human as well. We are small compared to the ages we have explored. Yet we, too, live within rhythms that repeat. We grow, fall, rebuild, learn, and rise again. Not in the same ways, not in the same shapes, but with the same quiet resilience that the earth has shown for hundreds of millions of years. The story of repeated giants becomes, in the end, a gentle reminder that cycles are natural, that returning to oneself is natural, that trying again, even after long stillness, is natural. Evolution's echoes reveal a universe that does not rush, that does not demand perfection, that trusts the slow work of change. As the last light grows softer, we step back from the vastness of deep time and settle into the present moment. The air feels calm, the world feels quiet, and you are here at the close of a long and soothing exploration held by the gentle rhythm of science, told slowly and with care. If you have enjoyed drifting through this story with me, it would mean so much if you gently tapped the like button, and if you feel comfortable staying in this calm little community of sleepy science tales, you are warmly invited to subscribe. Your presence here helps keep this corner of the world soft and welcoming. And if you would like to share where you are listening from tonight, or what time it is there, I always love reading those small glimpses of the world. They weave this peaceful space together across many places and many quiet evenings. For now, let the lights dim, let your breath slow, let your thoughts drift like leaves on a gentle current. Thank you for being here. Rest peacefully, and may your night unfold with the same slow patience and quiet wonder that has shaped life on Earth for so many ages.